All right, so if we're going to try to use Unreal Engine to create visual effects, then the best way to approach this is to make our scenes look just like Hollywood movies. So I picked 3 different screenshots, 3 different environments that we can create to teach us everything we need to know about visual effects for Unreal. So we're going to start with the Batcave from The Dark Knight. We're going to start really simple, but learn some key fundamentals in this lesson. And then I have 2 stills from Raya and The Last Dragon, where we're going to not just use Quixel assets, but learn how to create some assets of our own inside of Unreal Engine using the modeling tools, learn some dramatic lighting, introduce characters, and render this through Movie Render Queue and Sequencer. And then lastly, we're going to create this fantastical environment with particle effects, dramatic lighting, and some really high detail geometry, and put everything together by the end of this course. So let's get started with this shot from The Dark Knight. So if you want to go ahead and navigate to the TDK folder and go to ML_The Dark Knight start. So here we are. We're truly going to start from scratch and just start building everything step by step. So I'll include this image in the description, but just make sure to keep this on standby. And if you have a second monitor, make sure to keep this by your side at all times. For some reason, at a certain point, people think they get too good for reference, but the best pros, the best of the best, use reference as their holy grail, as their Bible, as their true north. So make sure to have it, and we have a couple images here to see what it looks like under different conditions. And through this, we'll learn a little bit about materials, about objects and actors, and we'll even start to dive into blueprints right away and start tackling the game development side of Unreal, building some really basic blueprints, but just to start getting our feet wet and understanding how these work. Most people try to avoid this until the end, but I think it's really important to embrace this in some really simple examples early on so we can start adding on top of our skills by the end of this course. Okay, so we started with this fairly empty scene. All we have are some lights. We'll actually end up deleting all of these, but there's 2 things that we're going to want to grab right away. So the first thing that I always like to do in every scene, the first thing every single time, is to add a human for reference. So we know exactly how big the scene we're creating is. And by using a human, usually a 6 foot tall human, because I'm about 6 feet tall, it really helps to immediately understand how big we're creating our scene, especially if our reference has people inside of it as well. If you press the add button here, we can add feature or content packs. And the one that I pick most often is the 3rd person example. So let's just add this to our project. So now if we go to our content example, this is going to add a couple different folders. It's going to add our 3rd person folder, but also our level prototyping and characters folder. Another thing I like to do just to keep everything organized is just drag these inside of our 3rd person folder. One thing to note, when you see these loading screens, it can kind of freak you out at first, but it's just because in Unreal, there are so many hard-coded references to other files. When you move something into another folder, Unreal will go through each file and fix all of the hard-coded references. So if you ever want to move files, it's really important to do it inside of Unreal and not just in your file explorer in Windows, because it's not going to go through and fix all of those references. And a thing that does happen when you open these, all these folders are going to be empty, but they're still going to exist until we refresh Unreal. You can always right-click and hit Fix Up Redirectors, and then that'll empty out that entire folder so you can delete the old folders. And now everything should be consolidated inside of our new 3rd person folder. So if we go into maps, we can see this is our 3rd person map, which is a great test level if you ever need to just throw something in or you want to make a one-off effect like a Niagara particle system. But let's jump back to our level. All right, so let's add in our character. So I'm in the 3rd person folder, and we'll go to Mannequins, Meshes, and then we'll grab our Manny skeleton. So if we look briefly, we can see how this is named as a SKM, skeletal mesh. So a good thing to know is that any character is going to be referred to as a skeletal mesh in Unreal Engine. Skeletal meshes have their own editor. So this is the skeletal mesh editor, and you can see that because we get this little pink icon, which also matches up with the pink color under any skeletal mesh. But we're not going to animate him or do anything fancy for now, so we just want him inside of our scene so that we have a good scale reference. And now if we look at our reference image, we're going to want a concrete for the ground. The ground is a bit more blue and the walls are a bit more yellow, and the walls are a bit patchier. They have these dark lines running down them, some leakage coming from the ceilings and things like that. So let's go into Quixel Megascans and start grabbing some assets. So this is Quixel Bridge, and honestly, this is one of the main reasons I love to use Unreal, is you have so many 3D models and textures at your disposal that are drag and drop. So it's easy to just start cramming a bunch of objects in your scene, but I want to start one thing at a time. So let's go to concrete. Any of these check marks are objects that are already downloaded, so some of these have already gone ahead and tested out. So this damaged concrete floor is pretty interesting. For now, we'll download everything as medium quality. Just so you know, low quality is a 1K texture, medium quality is a 2K texture, high quality 4K, and highest quality is 8K. Practically speaking, you're almost never ever going to download an 8K texture. It's just usually going to be overkill for whatever you're doing. And one of the things that can overload your system fastest is by having too many 4K or 8K textures in your scene. So I like starting with medium quality. You can always go back and grab the higher quality ones later if it's not good enough. But this is a good way to keep your scene lightweight and make it so you don't overload your GPU and start crashing Unreal earlier than you have to. This is essentially what it will look like when we are starting to run out of texture memory. There used to be a texture in our GPU's VRAM, but now it's kind of just turned into raw data. A lot of times this will happen at different LODs, which just means that the closer we get, it'll reveal different textures at different distances. So if anything like this starts to happen, it's a very easy fix. Just restart your engine, restart your computer if it keeps happening. And it does help just to limit the amount of tabs you have in your browser when you have Unreal Engine open. So I'm gonna grab this stained concrete floor, export that, and then I'm also gonna grab this worn painted wall material. Great. And when you're not using Quixel, it can actually take up a lot of memory on your machine, so it's good to close this. Don't keep it minimized if you're not using it. And then this will create some Megascan folders in our content browser. So we have our Megascans, where we have our surfaces. So surfaces are the textures or materials, and then 3D assets are any of the 3D models that you'll have in your scene. And now if we just do a quick comparison between our reference and our scene here, we can see that we probably have to double the size of our floor if they're in the middle, and then we'll have to duplicate it a couple times further down. So right off the bat, let's just change this floor to 2, and then there's 2 different ways we can duplicate an object. The first way is by pressing the Alt key and then clicking on our transform gizmo and dragging that. So this has created a duplicate. The other way, actually there's 3 ways. You can just copy and paste it, and that'll make a duplicate there, or you can right click it and go to edit, duplicate, or which is also Control D as a shortcut. So typically I like to just Alt click and drag here, and then let's just make sure that this is lined up perfectly. If we can see we're snapping by 10, we should set it perfectly at 2000 units, and then we won't have a seam between our floor. So let's now take those Quixel materials and apply them to our floor. So let's double click on our material instance and take a look at our material here. So not every material is set up like this, but we are getting the template of the Megascan materials brought in, which gives us some really easy controls to tint our base color, our albedo, change the specular, roughness, and normals. So let's just take this material and apply it to both of our ground planes. And we can see that right away we get some very obvious tiling. Now anything that we change in our material instance here is going to directly affect what we see in the editor. So we can start to drag some things around and see what these do. So if we want to change our albedo tint, we can click and drag this here, or we can change our saturation and set it to 5 and go really saturated, or we can set it to 0 and turn it completely gray. So I'm going to set this back to 1. So if you already have a good understanding of what PBR materials are, what your albedo, roughness, specular, metallic, subsurface, all of these properties are doing, just skip ahead to the next video. But briefly, for anyone that's not familiar, I just want to touch on what PBR materials are before we go in and modify this. All right, so let's talk about materials, what a PBR or physically based rendering surface is, and then we'll touch on master materials and material instances, which are the way materials are set up inside of Unreal. So what are physically based materials? So PBR is just a system where we have image channels that define how objects react to light in the real world. We want to create everything in a photorealistic way so that we can add lights into our scene, rotate our lights around, and have everything react dynamically in a photorealistic way. So every single PBR material consists of base color, roughness, and normal maps. So let's talk about what that is. So base color is what it sounds like. It's the raw color of the model, like we can see here. This can also be known as the albedo. And if you take any object and you got rid of its reflection and its shininess, this is what you would see underneath. You don't want any shadows. You want the pure base color that you would have of the object. If it was an apple, it'd be a very red map. So the best way to preview this is to go from lit mode into unlit mode. And this will basically remove all of the lighting data and reveal the base color of all of the objects in our scene. So if we go to the albedo controls here, if you want to modify anything that's grayed out, just click on the little checkbox. By clicking and dragging, we can see exactly what this effect does on our object. And now if we go to lit mode, we'll see the sort of effect that has. So that's albedo, but roughness has to do with the reflection of the object. So let's take a look at our chrome ball here on the right. So we have roughness and metallic options. So not every object needs to be metallic, but every object will have a roughness channel. And roughness refers to how rough the reflection of our object is. So if we set it to 0, it means it has 0 roughness. If we just click and drag these and we look at our chrome ball, when we have 0 roughness, it turns into a pure reflection, and we can even see our statue in the reflection of our chrome ball here. And if we go all the way to 1, you'll see that we start to lose that visibility and it starts to become very, very rough. Now, specifically what roughness is referring to, if you imagine the surface at almost an atomic level, how rough and jagged that surface would be. There's all of these micro bumps, even down at that molecular level. And that's what causes any object to have a lot of roughness. Whereas you imagine a chrome ball, or better yet, even just think of water as having 0 roughness, or a mirror, how smooth that surface would have to be. And that's because there's no micro detail breaking up that reflection. So I'll set this back to 0.2, and you can see that effect. That's one of the great parts of being in a real-time render engine, is you can start to see exactly how that looks, and you can even rotate around to see what effect that has on our object, and you can even see the reflection of the clouds in our surface here. And then we have the normal channel, and the normal channel is just a way for us to add additional detail to our object without adding additional polygons or triangles. So if I go to our wireframe here, we'll see exactly how detailed this object is. And you might expect this wireframe to have a lot more details, because when we look up close, we have all of this detail and it reacts to light in the way that we would expect. But this is actually coming from the normal map. So if I set this to 0, you'll see that our surface has a lot less detail. And this is because it's easier to process this information at a per pixel level in the normal map, as opposed to creating geometry for the equivalent of every single pixel. So if we look at our normal map image here, we can see all of the detail even at this micro level. And the higher resolution that you have this image at, the more resolution we'll get on screen. And our normal map is not something that you would create by hand in Photoshop. This is data that is best created by a computer, typically when baking down high resolution sculpt or photo scans and condensing it down into a texture using an automated process. So in Substance Painter or ZBrush, you'll take your high polygon mesh, reduce the poly count, and then use a process called baking to create these normal maps and take the detail in the high poly mesh, but convert it into this normal map so we can use it on something with significantly less polygons. So Nanite has definitely changed the game and allowed Unreal Engine to use a lot more polygons, almost to the point where there is no restriction on the amount of polygons that we have. But if you're going to model the surface, this would require an insane amount of geometry for every little nook and crevice that's existing on here. A lot of times it is going to be easier for us to have this micro detail happening at a per pixel basis instead of a per polygon basis. So it's still a good idea to use normal maps wherever you can. We can start to increase our normal strength. Another thing we can do is we can also set it to a negative value and invert it. And instead of having these look like there's crevices that are going in towards the center of this object, we'll start to have these bumps going outward. So there is a direct relationship here, and normals are affected by the lights in the scene. you can see that the light starts to catch on the sides here based on where that light is. And if I move it to the left here, you'll see that it looks like the left side of these bumps are catching the light. So now if you're coming from another 3D software, I want to briefly touch on master materials. So this is one of those things that exists because we are working inside of a game engine, not a render engine. So things are set up in a slightly different way. So instead of every single material having its own designated material graph, like you might be used to in Maya with Hypershade or Blender with their shading networks, whenever you right click in the content browser and hit material here, we're creating a new master material. So type in we'll just call this test material. And this is what every material looks like. So by default, every material comes in as an opaque surface, and it has the default lit shading model. Most objects exist with these settings, and anything that you'd see in Megascans is going to come in with these settings. And now we can see what makes up a material. So we have our base color, we'd have our roughness, we have our normal. We can also add emissive, so we can make this material emit light. We could turn it into a metallic object, and objects are either metallic or they aren't. There's no half metallic objects. So master materials are essentially templates. So what we're looking at here, we can see it's MI_Japanese statue, and that stands for material instance. And what's going on here is we're basically getting a template from the parent material. Inside of our master material, we can define these different properties that we want to expose in our material instances that we know we want to change on the fly with our material instance. So if we look inside here, this is the shading network, and this is what's going on under the hood. The Megascans materials are deceptively simple. If you double click on our material function here, you'll see that this is the shading network where we're adjusting the base color or the albedo, the metallic, the specular, the roughness, and the normals. So this is where the math is going on. Like normal strength. And this normal strength is what we're adjusting in our material instances. But again, these master materials are the templates so that we can swap out the textures, we can change the parameters, and customize everything on the fly. Before moving on here, I've had a couple people that have been a little bit confused about why we even have this in the first place. And some people are just wondering, why don't we just adjust everything inside of our material editor here? Because that's what a lot of people are used to. So I just have a really simple analogy to explain why we need to work in this master material to material instance relationship, especially when working inside of a game engine. So let's say we're at a high school and everyone needs to get their yearbook photo taken. So we have a teacher that needs to print out yearbook flyers for the freshmen, for the sophomore, juniors, and seniors. Now, what's the fastest way to print all of these flyers out? If you were just going to hit Control P and you printed one copy at a time, you hit Control P, go through the settings, hit print, one copy. Control P, go through the settings, hit print, two copies, etc. And we just do that one by one by one. You can imagine how long that would take for 400 students. So what's faster, doing that, or do we tell the computer to print 100 copies at a single time? This is the idea of instancing. So we know we're going to use the same thing over and over and over and over again. And depending on how you give a computer instructions, it's going to be faster or slower. And when we create instances and use these predefined templates, like a yearbook flyer is just a single template, and we tell it we want to use 100 of these pre-existing templates versus printing individual copies, it's going to be able to process it a lot faster. But now let's say we need different information depending on the grades. So the freshmen need a different flyer saying we need to meet at the gym at 10 a.m. The juniors need to find out that they need to meet there at 2 p.m. on the following day. And the seniors have completely different instructions. So we need to build our template, our yearbook flyer, in a way that we can just swap out and change the specific things that we want to, like the headline, the color of the headline, and what time we need to show up. So what this would look like is we're going to make our master material template, and then in each instance, we can give it individual instructions. Like we want one to have less roughness, we want one where the albedo is darker, And one, we're going to change drastically. We're just going to actually swap out all the different texture samples, but the base instructions are going to be exactly the same. So when we look at our material graph for our master materials, we have predefined instructions. And whenever you see the term parameter, these are what we change in our material instance. So by the end of this course, we'll dive in deeper and we'll actually build a master material ourselves and show you exactly what are the key things that you need to know to build master materials that are flexible and allow you to make dynamic changes on the fly. But just so we can get started and dive into creating our scene, we're going to start just by using the Quixel asset material instances because they're pretty good at getting us up and running with adjusting PBR materials on the fly. So for this material instance, we have our albedo tint, our albedo controls. We can change our roughness, our max and min roughness. We can change our specular, which is the overall amount of reflection. If we set this to 0, it'll remove any reflection from our scene. And if we set it to 1, it'll double the amount of reflectivity we have. There's a couple exceptions to this, but 99% of the time, you're going to keep this base specular set to 0.5 unless for a specific creative reason you want to change it. Otherwise, you'll want to change the roughness before you change the specular. Like we said, we have the normal strength. And then below here are our texture maps. So we can swap these out for any other texture in our project. So now we're back in our Dark Knight cave. At the very beginning, believe me, we're going to get through this pretty quickly once we get up and running. But now we have this problem where we can see our texture and it's very clearly tiling across our entire surface. So if we double click this material instance, we're going to have our material instance settings. Now if we scroll to the bottom, we can see that this has a Megascans surface material template. And one thing I like to do is I like to set these either to a plane or a cube. Cube just lets you see each side individually. And if we look here, we can see that our object is tiling in a very perfect way across our entire floor. So the first thing that we can do is we'll want to change our global tiling. So tiling is an X and Y. If we just drag this, we can see that it stretches it out in one direction or another. So if I set it higher, it's going to tile more frequently. If I set it lower, it's going to tile less frequently. So off the bat, I'm going to set this to 0.25 in the X and the Y. And we can see that already this looks quite a bit better, but especially when you're looking down long corridors, you can start to see some of that repeating over and over again. So a really simple way to avoid this without doing any complicated shader math is by adding a rotation angle. So rotation angle is between 0 and 1, where 0 is 0 and 1 is 360. So if I set this to 1, it's going to look like there's no difference. If I set it to 0.5, it's going to do a 180 degree rotation. So if I set this to 0.25, it'll be a 90 degree rotation. But if we set it on sort of an off axis number, something like 0.15, we can see that this starts to break up how this is tiled. If we rotate our camera, we'll start to see that same reoccurring tiling. But like I said, if we're in a long corridor, oftentimes this will do the trick just to get it started. Now that we've stretched our material, if we get up close to our mannequin here, we can see that our ground is actually pretty low res, and this is because now we've tiled it up a bunch. So let's take a look at how to update our textures and convert them from 2K textures up to 4K resolution. Any Quixel asset you download is going to have a 7-letter key at the back here. So we have VLXLEIV. So if I type this in, VLXLEIV, and I hit enter, this should bring up the exact surface we had before. So now if I click on this and I want to update this from medium quality to high quality, we're going to have to download our material again and then add it to our scene. Now we're going to have two sets of textures and it'll label it 4K here instead of the 2K texture. And you can keep both in your scene, but usually I like to delete the previous one, the 2K version, just to make sure that we're not confused. So I'm going to remove these and I'm going to open up our new material. So now if we enter the same settings, we set the tiling to 0.25 and we set our rotation angle to 0.158. Now we can swap out our material. All right. And now when we look at our ground, we still have a lot of detail up close. And now that we have this really high res floor, another thing that we can do is we can start to crank our normal strength, especially when we're looking at a light, you can see how smooth it looks here and how much extra detail we get by setting it to 5. So now let's create our walls. I'm going to go to the quick add actors menu where we have some primitives here. So we have cube, spheres, cylinder, cone, and plane. Use these a lot, especially when blocking out a level. We'd want to make this about 9 feet tall, like a typical ceiling would be. So we can set this to about 2.5, let's say. We go here and press the end key so it snaps to the ground. And then let's make these a little bit thinner. And let's drag these out so that they can exist on our walls. And we'll set this to 1,000 here. We'll zero out our x-axis. And now we can scale this to reach the 2,000 units that is our wall. Cool. So now we've scaled that out. So you'll see in a bit, Lumen works best when objects completely intersect with each other. It does a good job most of the time when they border on each other, but sometimes it's good to give it a little extra nudge. So I'm just going to scale this up vertically. Otherwise, it could just sink it into the floor just a little bit more. But let's keep it right there. All right, so we have our wall here. Let's duplicate it and make the opposite side of the wall. And then let's just add our back wall. And we'll set this to 3,000 units in the x-axis. We'll rotate it 90 degrees. Another reason why keeping snapping on most of the time, especially in this layout phase, is fairly helpful. And we'll set our Y to 0. Now, one thing to notice here, this scale lock is on. And what happens here, if I change our x-axis to 20, which would just cut this in half, we can tell on the red x-axis that that's the axis that we would need to scale down on to make this less wide. So I'd set it to something like 20. But if this lock is on, it's going to scale every single dimension. So it's going to scale our Y dimension and our Z dimension. So if I undo that, in this case, I would want to uncheck the lock and just scale it on the x-axis. And then we keep our height, we keep our width of the wall, and everything's working as we'd expect. And then we'll just duplicate this one more time and add our back wall as well. All right, so now let's grab our worn painted wall material and drag that onto our wall. And now you can see, because we stretched this out so much, or 40 times wider on our x-axis, now this is reflected in the texture. So we can open this up and we'll need to change our tiling in the opposite way. So if we want this to tile more frequently, we would want to increase the tiling, and it's 40 times bigger. So let's just set this to 4 and see where that gets us. And we can see here, it's not so bad. So we could also reduce our tiling in Y to something like this, like 0.5, and this will start to stretch out our texture in a way that at least looks correct in terms of the scale of the world. But again, we have that same problem where we have these clear, large artifacts that are repeating throughout our wall. Oftentimes, it can be helpful to pick materials that have more subtle features. If they have large features like this, it makes the tiling become very, very obvious. But we can do the same trick with our rotation angle, and we'll just start to drag this until it does remove some of that tiling. Another option we have is we can offset this in the X and Y. This happens before the rotation. So now that I've rotated, it's going to offset at an axis. But from here, we can start to dial in the look of the tiling of our material. All right, but now if we look back at our example of what we're trying to create here, again, always want to look back at the reference. We can see a couple things. One, we can see that our wall up here is pretty bright and contrasty. In this example, the floor is actually brighter than the walls. One reason for that is that the light is hitting it more directly, but still, right now, our wall is brighter than our floor. So now let's start adjusting the albedo color of our textures. So if we go to the albedo settings, we have our albedo tints and we have our albedo controls. Oftentimes, setting these controls first is a good idea. We want this to read as gray concrete, so I'm going to desaturate this a little bit. If we go to our unlit mode, we can see that these are actually fairly gray. They're really just looking a bit yellow because of the color of our sun. As you can see on our mannequin here as well, he's almost perfectly gray in our viewport, but if we go back to lit mode, he does appear to be yellow just because of the sun. So now we can set the brightness to be a lot lower. But as we set that lower, we can see we still get a lot of contrast out of the darkest darks here and the whitest whites. And again, if we look back at our example, other than a few spots, it's a pretty flat gray. So one thing that I'll do here is I'll set this contrast to 0.5. Typically, when you decontrast something or reduce the contrast, it will make it brighter. So you'll usually have to compensate by making it darker as well. So the more you decrease that contrast, it's not surprising to have to set this brightness to something very low, like 0.05 or even lower. So it's usually good to check this in unlit mode, and we can see that 0.05 is probably a pretty good brightness level for us in this case. But keep in mind, these are very context dependent and really depend on the albedo image that's being input in the first place. And now we want to flip these. We want our ground to be a little more blue and we want our walls to be a bit more yellow. So we can just take our color picker here and start dragging it towards yellow. We just want to inch it. If we go too extreme, it'll start to look very unrealistic very quickly. And we can drag it here. A couple things to know about this color picker. We have our saturation here. So our saturation is represented on this slider here, but we are literally, these are doing the same exact thing, whether you drag it here or click it on this visual slider. So whatever is easier for you to understand. You can see there's also a saturation bar there. And the same goes for value. Value is just another term for brightness. So same thing, the darker we get there or on our slider, the darker our material will appear. And if you just want to change the hue or want to rotate it around the wheel, but you want to keep the saturation the same, that's what that hue control is for. So that's another useful slider if you just want to change the color itself, but not the brightness or the saturation. So we'll press OK there. And now let's tint our floor. So I'm going to double click on that material instance. Now we have the same albedo controls here. So here we want it to be more blue. So if we want to keep our value the same, but we want it to be more blue, we can reduce our red and green value. So if we set this to 0.5 in the red and 0.5 in the green, we can see that that's now made it too blue and almost purple. So then if we pop this open, we can just reduce our saturation to something like 0.1, where we're just starting to inch it. And we'll make this a little bit darker so they line up. And it is pretty subtle here, but now we can see that our wall here has gone a little bit green compared to our blue floor there. So now we'll just take this and we'll pull out just a little bit of green so it has a warmer, sandier tone. And there we go. For now, that should do the trick. Our floor is a little bit brighter, our wall is a little bit darker. Now let's make sure to apply this material to our other walls here. So I'm going to click on the Browse button. And now that pops up in our content browser. And now when I click on this wall, I can just hit the Use Selected Asset from Content Browser, and it's going to know to grab that material. And now if I apply it to this back material as well, the tiling is going to be scrunched up when compared to this because this is twice as wide as our back wall here. Honestly, I don't think we'll notice it, but you would just take that same material, duplicate it, and make another instance, and we'll change this to the number 2 variant. Let's make sure that we're actually using this material on the back wall. And because we've used our pre-existing template, and we can set our tiling from 5 to 2.5, and now it should have roughly the same tiling between our walls on the side here and our wall in the back. But we do have this repeating texture here. So now I'll just offset this in our X to make that a little bit less obvious. Great. All right, so before moving on to adding in the ceiling, I want to talk about decals, because decals are a thing specific to Unreal that will really start to elevate your workflow, and it's something that you don't have access to in other render engines. So you can find these by going to the globe icon in Quixel Bridge and going to decals. And let's go down to leakage decals. Now these are really quick ways to add grime and detail to your scenes without having to texture anything by hand. These are drag and drop materials that you can pop onto your scene and across several objects at a time. And if you use them the right way, they can really elevate boring standard scenes into something pretty special. So let's grab a couple here. The best way to keep our scene optimized is with the same idea is instancing our materials, but it will be by using just a few decals the right way. So I want to make sure to switch from high quality back to medium quality before downloading these because we're not going to see them up close. And we want to find decals that look very different from one another. So that way we have 3 or 4 unique decals that we can move around our scene, rotate them, scale them around, change them, and instance them in the same way that we're going to instance materials by just making slight modifications to the same few, but we're only going to load in a couple textures as opposed to 20 different original textures, which again will start to fill up our texture memory really, really fast. And so now we have a new decals folder in our content browser with the 4 that we've selected. And let's start to just drag these into our scene and see what they look like. If I haven't mentioned it already, if you press G, that'll swap into game mode, which is what you'll see inside of your game. It basically removes any bounding boxes or any icons that are associated with widgets, but sometimes you want to see those so that you can align them. Decals by default are brought in with X facing downwards. So if you see here, this blue arrow, that's the direction that this decal is going to project from. So if I rotate this towards our wall by 90 degrees, you'll see that now it's projecting correctly. And let's just scale this down to something a bit smaller. And you can see these need to cover whatever they're projecting onto. So this really thin green bounding box needs to be intersecting with this geometry. And you can see from here that it looks like this decal is upside down. So we'll want to rotate this 180 degrees. And there we go. So we'll thin this out just a little bit. So cool, there's our first one. And we'll just add in the rest of them so we can start to see exactly what they look like. One thing you can do too is if you just duplicate this over here, you can go to our next one and just drag in the new material. And this one we can scale out in X because it's a different resolution. And there we go. There are 4 different decals that all kind of come in at different sizes and shapes. And now we can just take these, and as long as we only bring in a couple different materials and limit the amount of textures that we're bringing in, now it's very quick to start populating them around our scenes. Another really important tip with this is a lot of times when you have the corners between 2 walls, usually these little biomes will start to form on the cracks of the walls, going up the walls and outwards. If you're familiar with ambient occlusion, this sort of starts to mimic it, but it's always better if you can find a real texture. You can see here, as soon as we start to get close to the wall, they start to get this barcode effect on the side, and it's just because our projection is a bit too big. So we could either stretch it in Y, but we could always scale this down in X and just make this really thin. And then if we start to bring this on the ground, we can make it so it just starts to appear on the very edge, and we can line that up. And now that we've set up that correctly, if we duplicate this over here, we can do a negative scale in our Z just to bring that out. We don't want to make it too uniform, but just kind of populating these out. And around here, we could add our other materials in. But now we get a lot on the ground, and we still get this harsh cutoff on the wall itself. So let's make sure to add something on the wall. So we'll rotate this 90 degrees and bring it really, really close to the wall and rotate it 180 degrees in X. And now you can see where those overlap. If we swap this out for another texture and make this a bit smaller, you can see that now we have some nice breakup coming up and down our walls, and we can easily customize these however we want to inside of our scene. Decals are one of those things, because we're instancing them and just reusing the same thing over and over again. We've used hundreds of these when building environments for LED walls. You can add as many as you want, and it really won't affect your render times. It's also worth noting, depending on how close we are to the edge, they'll start to fade in and out. So if you're very particular, you turn off your snapping and just really start to dial in exactly where you want these to land. You can just have them start to fade off so they're not full intensity. And the same is true if you rotate them. You could always, let's turn off snapping here. You can always have it where the bottom fades out, but the top is still there. So you can get pretty creative with these and really go to town on an environment. This is pretty basic at this point, but we'll make sure to keep pushing these more and more, and I'll show you some more tricks later on. And then lastly, if you have a couple that you're pretty happy with, you can also just select the whole group of them here. Now we have all of these selected, and you can duplicate things as a group. So I'm gonna Alt, click, and drag on Z here. And now we have these clustered, and because we have this perfectly square layout, we can drag these across, and we could still rotate these around, do whatever we want with them as a group, and they'll all stay together as long as they're selected. Cool, and now we have some pretty interesting breakups across our wall there. Let's just toggle the before and after to see how big of a difference that makes. And that's nice, and really starts to break up any sort of tiling that we might have seen beforehand. And just to start blocking out this scene, we don't have to get too fancy. Let's just turn our angle snapping back on so we can rotate this 180 degrees. And then we'll align this to the other side here. Now if we pop into unlit mode, we'll still see that these have the same amount of effect. We can see that it's actually changing the albedo color, or if we change the roughness or the normal intensity, it'll also change. in our viewport. Let's add a concrete crack decal, and let's see how decals can affect the normals of our objects. So we have these asphalt cracks here, and if you just look at the icon, you can see that it does look like there's some depth to these. So let's add one of these to our scene, and let's see what it looks like on the ground. So if I drag these on here, they're pretty thick by default, but if we get up close, you can see that they do seem to make a bit of a difference, especially, again, when looking at the sun. But if you open up the material instance here, let's just crank the normals. Sometimes you do have to be a bit more intense on the normal intensity for decals just to make sure that they show up. And you can see if we crank this anywhere between 2 and 4, it becomes really obvious that they're showing up, but it does start to look fairly dark. So one thing we can also do, if we swap to unlit mode, we can see, okay, yeah, it honestly looks like it's a completely different concrete material versus just cracks existing in the same material. So now that we're in unlit mode, now for some reason, the decal master material is set up differently than our regular surface materials. And one thing that is pretty odd to me in this setup is that they change out the color tint and the nice color settings we had before into a color overlay. Now, I'm not a huge fan of this, but we'll get into modifying these more later. But if I just make this brighter, all these values also go higher than 1. So I can even set this to 1.25. And if you look here, it's subtle, but we're a little bit green and a little bit yellow. So because we know if we're too green and too yellow, we can start to drag our color in the opposite direction. So here it's obviously more green, but if we start to drag it into this bluer realm, it'll start to tie in closer to our concrete. Now if I talk back to the lit settings, now if I look at the concrete crack, it does start to look like it's indenting the concrete floor instead of being this dark outline that we had originally. So a lot of times, if I'm trying to balance the colors of any of these Quixel assets or the assets in your scene, it's a really good idea to do that in unlit mode. Make sure everything looks like it's correct on the surface, because it's a bit hard to tell exactly what that color is when you have different colored lights in your scene, like the sunlight or any other point lights. Cool, so now we'll just click and drag these and duplicate a couple across our scene just to break up the ground. And again, if we use that fading setting, if we just lift this out of the ground, we can see the further we get, at a certain point, it'll start to fade out. And based on how much it's faded, it will also fade our normal intensity. So if we just start to lift this up, we'll see that we get a lot more detail out of this crack. It has less depth, and it's not quite as black, which in this case can look a little bit more believable and integrated versus some of the dark lines that we're getting from our really intense cracks. In fact, I'm just going to lift those up and just help them integrate a little bit more. Now, one more thing we can do is we could add puddles of water that reflect. We can make them really glossy or set them to 0 roughness, so they're very, very reflective, just like water. But if you type in puddle and we select decals, we're not going to get any water puddles, but instead of searching for puddles, it's going to be weird at first, but just trust me, if you search for blood, they have these blood stains decals, which I guess are graphic content now. That's new in Unreal 5.1. And we'll just try to look for some very large puddles. So let's just grab these two. And again, just make sure these are at medium quality so that our texture memory is still fairly low now that we're starting to add more and more things into our scene. So we'll export our blood materials and close out Quixel Bridge. And now let's open up our material here. So I'm going to set this to a plane. And now decals are a bit awkward to preview in the editor because if you see them over the sky, they don't really show up because they need to be over a opaque surface to show up correctly. So a lot of times I'll just set it to a cube, and you can see if we get up close to the top here, they do have some nice shininess, but one thing is clear that it is definitely red and not neutral colored or maybe blue or green like you'd expect a murky puddle to be. So briefly, we could take our color overlay and we can just take all of the red out and set our red to 0. All right, so now let's drag what is now our water material into our scene. And one thing that you can do, especially on characters, a lot of times you'll want decals on the floor, but if something's moving through the scene, it's really hard to line up every decal where it doesn't affect another surface. So one thing that we can do on any actor is in our details panel here, you can just search for decal, and there's this receives decal option, and we can just uncheck that. And now no matter where we drag this decal or any other decal in our scene, it won't be affected. And now you can see that we can put this under our actor as well, and we can get a really nice reflection from our new water decal. And again, depending on how far away we place this, we can change the opacity of our decal, which will also change how reflective it is. Cool. And one last note, there's another setting here called sort order. So if you ever have something like this, you would expect that the water would go on top of our crack decal. So if we just change the sort order to 1, whatever decal has the highest sort order will be placed on top. So if we change this to -1 or 0 like it was, it will go underneath. By default, everything is set to 0. So most of the time, if you have something, set it to 1, but you could set this to 1,000 or any number that you want. So let's do the same thing to our other blood splatter. We'll just change the color overlay here and change the red channel to 0. And it'll give us this blue-green tint, which will kind of work for what we're doing. And now we can start to instance these around our scene. Cool. Now this will just get us started. Again, we're just trying to block it out and see how all of these things work together. But now we have some pretty nice integrated decals across our scene. Hopefully we're starting to understand how materials and material instances work and how we can modify them. But for now, I want to briefly talk about blueprints. So if we take a look at our scene, we have these reflective, emissive lights that are grouped across the entire ceiling. We can see here that they're a perfect grid all the way down, which if they're cloned in the same objects, that means we can instance them. But if we were going to try to drag these out one by one across our entire ceiling, it's going to take a really long time. So I think this is a good opportunity to try to replicate these using blueprints. So if you go to the UE VFX folder, go to Assets, and then Ceiling Tiles, I prepared this really simple texture. It's just a white texture with a little bit of broken up information on it and a black edge, just like our references. And we're going to use this to create our ceiling tiles. So first things first, let's create a cube and drag it into our scene. So let's make a material for this cube and let's call it mm_ceiling tile 01. And let's create a very simple master material here. So if we take our texture and we drag it into our scene, that'll automatically create a texture sample inside of our material graph. And the main things we want to do here is make this emissive. So I'm going to plug our RGB into the emissive color, and I'm also going to plug it into the base color. Now if we save that, and if you're editing a master material and you want to see it update in your scene, you have to either save it or hit apply every single time. Which is another reason why material instances are nice, because you don't necessarily need to save them to see your changes. But now let's take our master material and we can drag it onto our object here, and we can see, great, now we have black edges on the corners, and if we preview this as a cube, we'll see the same exact thing over here. So one thing I'm going to add is I'm going to drag off of our texture sample, and when you look here, you're going to see all these different menus, and it seems like there's so many. Again, at the end of the day, there's only a couple that we're going to use, so I'll make sure to point out all of the ones that are most commonly used, and a lot of them are just simple math nodes like multiply, subtract, add, or divide. So in this case, I'm going to multiply this by 2, and we press apply. So one thing I'm going to do, let me just hide our light source for now, and it'll actually make this cube emissive. So it's emissive because our scene has lumen enabled, and lumen is what casts the lights and gives us these really nice reflections around our scene. You can see that it will even appear in the reflections of the puddle if we place it in the right place. So we get a nice reflection there. And now if I set this to something like 0.2, we'll make it darker because we're multiplying it by a value that's much lower. And you can see it has a direct effect on the brightness and how much light is cast into our scene. So again, this is our master material, the template that we're creating. If you want to take a master material and create a material instance from it, all you have to do is right-click a master material and hit Create Material Instance. By default, it'll add _inst to the end of your node, but if we want to keep our naming convention, we'll swap out mm for mi for material instance, and then let's open that up and hit Save. And you can see here, we don't have any settings. These are just asking what our parent material is, but we don't actually have anything that we can edit in here like we did with our Quixel master materials. So we need to set up some basic parameters so that they'll show up inside of our material instance so that we can edit it on the fly. So let's just apply this material instance to this cube, but let's make sure to click our master material because that's what we want to edit. So if we need to see that, every material instance has a parent, and you can just double click that to open up the template that it's based off of. So if we wanted to create a brightness setting, what we have to do is we have to create a parameter. So we can drag this off and type in parameter, and it'll give us a ton of different options here. But the most common ones are scalar parameters, and we can type in brightness. And a scalar parameter is just a number, and specifically, it's a floating point number. All that floating point means is that it has a decimal afterwards, whereas an integer is a thing where you don't have any decimals. So this will come into play in a bit, but all you need to know for now is that it's a scalar parameter. Scalar means one number. So if you multiply anything by 1, it'll just be itself. So let's set this to 1 by default, and let's hit save. And now let's go back to our material instance. And now we'll have this brightness global scalar parameter that we can adjust. So now we can drag this up or down, and we can see that now that I've, made it 1,000 times brighter, it's casting a lot more light into our scene. When you do these very extreme values, it will start to break lumens. So just be conscious of that. So let's set it back down to 10 instead of 100. And you can see, okay, yeah, it's making a pretty big difference inside of our scene. And we could also set it to something low, like 0.1. So that's a scalar parameter. It's just up or down. The other type of parameter, if we right click here, is going to be a vector parameter. So a vector parameter is, instead of one value, we get 3. It's nice to think of a vector as an R, G, and B image, 3 vectors, RGB. It has the option of being 4. And now let's set our default value to 1. So we'll drag this value up to 1. Now if we press save here, we'll get a new parameter in our material instance. So brightness will now be gone, and it'll be replaced by color, because now the brightness isn't connected, the color is. So now we have a color parameter, and now we can start to tint this into any color, and you can see it will also have the same effect on our scene. It'll cast a different color light into our scene once Lumen catches up with how we've changed it. And specifically what's happening is this R, G, and B, these 3 numbers, are being multiplied by this image's 3 RGB values. And if you desaturate a vector, it'll act the same way as our single floating point scalar number. And then you just bring the value slider up or down. But let's just set this back to 1 and start building our blueprint. Cool, now I'd like to briefly talk about blueprints, because a lot of times people can be pretty timid and not sure how to jump in to this topic. So I want to look at how we can use them to create assets inside of our scene with a really basic example. And we're going to use them to create the ceiling of our Batcave here. So how can we build a very simple blueprint to duplicate our cube across the entire ceiling here? And now that we're back in our content browser, let's just right click in the open space and create a new blueprint class. So this is going to open up a new menu. If you remember back to what I was saying before, an actor is any object that's in our scene, whether it's a cube, whether it's atmospheric fog, whether it's a light, whether it's a decal. Every single object that we can even place and can be visible in the outliner is an actor. So at the very least, every blueprint itself has to be an actor. So let's call this BP ceiling tile 01. And let's start to open up our blueprint editor. So each time we open up a new editor, it's its own little program that we're opening up. Blueprints can get fairly complicated, but really all we need to know just to get started with blueprints are 2 simple things. The first thing you need to know is that it's a visual, node-based scripting language, and this may sound complicated at first, but you don't need to know programming to know this, although if you do, it'll give you a head start. We really just need to remember 2 things. The first is that we're going to get data, like the location or scale of an object, the brightness inside of a material instance, or the intensity of a light. Anything that you see in the details panel of any actor is something that we can get the data from inside of a blueprint. And then we're going to set that data by executing a script. So that's where the scripting language comes into place, and we're going to modify this data using simple math and programming logic. Now, why we use blueprints is that inside of a blueprint, it'll allow us to combine more data into a single actor. So if you're creating an RPG and you're creating a game with a barbarian character who's holding an axe, you might want to combine the skeletal mesh of the barbarian and the axe into one blueprint so we can take that data, modify them together inside of one single actor instead of two different actors living inside of our scene. Now in blueprints, data is stored in two ways. They're stored as components, like an axe would be a static mesh component, and variables. So components are actors in the 3D world. We're just nesting them inside of a blueprint. And variables are raw data stored inside of the blueprint. And we can use the variables inside of our scripts to modify the math and the programming that's going on. And again, we modify this data through simple math by executing a script. So there's two different ways that we can execute scripts. The first are through construction scripts, which will happen anytime you place an actor in the scene, anytime you move it around, anytime it's constructed. Or you can do it through events. And events will only happen when you're playing your game. So one of the first events that's in every blueprint that you create is an event begin play, which will execute as soon as you press the play button. There's also on overlap, when you can have a bounding box associated to any actor, and this will execute when those two actors overlap with each other. You can also do it on ticks, so every time Unreal renders a frame, this event will execute, so it'll execute constantly. Or you can create custom events, so you can trigger a part of your script whenever you need to. And that's the entire system that we have to worry about to get started. It's just 4 new terms: components, variables, which are the data that we store inside of our blueprints, and construction scripts and events, which are the ways that we're going to execute our scripts. So if you look at our blueprint here, we have a little components tab here, and this is where we can add different objects into our scene. So we could add a static mesh. So I'm just going to add a couple of things here just to show that it really is just a list of things. It's nothing particularly special. Let's add another static mesh. We can add a cone here. We can add a skeletal mesh, so we could add a character, and we could set this to Manny, our mannequin, or here we have the Unreal 4 mannequin. We can take this cone, can even give him a little hat. How adorable. And we can even add things like decals. So if I search for a decal, I could parent this to our skeletal mesh so it always follows. I can shrink this to be a lot smaller. And now if I take this blueprint and I put it in our scene, now it's all combined into one single actor, and whatever I do to this actor, it's all grouped under the same blueprint. And if we look here in the details panel, I'm just going to drag down. It's sometimes can be hard to see when you're first doing this, but right above the search panel, every actor actually has its own list of components. So we're seeing the same list here. Whatever I'm seeing on the left here, this component list, is the same thing I'm seeing on screen right here. And if I wanted to change any of these, I could just click on this component inside of here, like this decal, and move it around further. So here we have our list of components, which another way to think about it are these are the children, and this blueprint is the parent. And then once we have this list of actors, now we can do different things with the data. So here are our components, and then if we scroll down, we have variables. So we can add different variables here. And variables are just different types of explicit data. So here we have our float data. Like I was saying, that floating point number, that scalar parameter is just a float. An integer is a whole number that can't have a fractional part, meaning no decimals. And then we have strings, which is a piece of text. We have vectors. We have transform data. So you don't have to memorize any of these right now, but they're just different forms of data. These are just different types of things that we can have talking to one another. So we have components and we have variables. That's our data. Now we need to send and receive that data and do things with it. And we can do that through 2 means, which are construction scripts and events. So this is how we're going to modify our data, meaning we're going to either modify our components. So any of these components we can just drag into our scene here. And now with these pins, now we can create little scripts and programs and just take our components, take our variables, do some really simple math between them, and cause an output. So for example, just to really show how simple this is, we're just modifying data. So I've just dragged in my skeletal mesh. If we take this pin here and we just drag it out, just like the material graph, it's going to give us all these different options, and you're going to say, oh my God, what did I get myself into? This is way too much to learn. They're listing every possible thing you could ever do to modify this data. In the end, we obviously don't need to do 98% of what's in this list. The most common things that you're going to do is you're going to get data and you're going to set data. So if you're getting started, you can type in get and you'll see all of the things that we can get. So we could get the world location, we could get the world rotation, we can get the data from the skeletal mesh, we can get the world scale, or we could set the world scale. So let's do that. Let's set the world scale 3D. So on the construction script, it's going to execute this. So it just means that this construction script is going to execute every time this object is moved. So when we do this, we're going to have the skeletal mesh set a scale of 3. So let's set this new scale to 3 and XYZ. And now let's hit compile. And you'll see, okay, it's now made 3 times bigger. So I think a lot of people jump into this. It gets very complicated very quickly. At its core, it is just data, and we are executing a script and we're modifying data. For example, if we wanted to get data, so let's say we want to get the scale. Now, if I plug this back in, all it's saying is we're going to take the skeletal mesh, we want to get the scale of it, and we're going to set it to that scale. So this should return it back to its normal size because it's saying whatever it is, we're going to set it to that. So like we would expect, it's set back to 0. But the thing that we can do in Blueprints is we can modify it. I have to take the decal, and let's keep our fun dunce cap on the guy. Why not? So now let's modify the world scale. So now we can do some simple math. So we can just click and drag this out and type in multiply. And we could just type in a hard-coded reference here. So I could set this to 2 if I wanted to. But another way to do this, if I click and drag this pin off, every time you have an empty pin, you can promote it to a variable. And it'll automatically create a new variable down here on the bottom left. And I can name this scale. And now I can control click on this pin and drag it off to remove it. And let me pipe this new pin in here. And now if I expand the details on the right side here and I'll scroll down, the default value will show up on the bottom. You need to compile to see this whenever creating that material for the first time. And you can see our skeletal mesh has scaled up again now that we've compiled it. And now we have this new vector down here. So why would we want to create a variable here instead of hard coding in the scale? Well, just like with a material instance, in a blueprint, we can expose these parameters or these variables so that they'll show up with our object inside the scene. So by clicking this eye icon, it'll make it visible in our editor. All that's happening is I'm enabling the instance editable. It's doing the same exact thing there. And when I hit compile, if I select my blueprint now and I look in the details panel, you'll see that we have this new scale option. And now we can dynamically change this in the scene so we don't have to recompile our blueprint every single time. The other thing we can do, we have construction scripts that execute, but we also have the event graph. So these are also executing. We'll see these little execute knobs. Same exact thing. But these events happen when you play your game. So we haven't hit play so far. So let's just hit play and we'll see what happens in our scene. So we haven't hit play so far. So let's just hit play and we'll see what happens in our scene. And you're going to see this. And again, it's one of those like, what just happened? There's these two weird circles on my screen. I can move around now if I hit WASD, but everything that I had hidden is now visible, which is pretty weird. And when we go back, it looks like we're back to normal. So let's talk about what just happened. So first things first, whenever you hit play and you play your game, anything that you hid in your viewport is going to become visible. This is just how Unreal is set up. So a really important thing to note is whatever you see here, if you're hiding this, this has no bearing on what happens when you play your game, when you simulate your game, when the game itself is playing, which can be very confusing. If you actually want to just hide it forever and make sure it will not show up in your game, any object, if we're looking at the details panel here of our light source, of our sunlight here, There's a couple things we can do. If you uncheck Effects World, it will not turn back on. I can also uncheck Visibility, or if I just want to hide something in game mode, I can check Actor Hidden in Game. And these are the 3 different ways to hide something when you render. If you see these weird circles on your screen, they're actually the mobile joystick controls. For some odd reason, when you first load up Unreal, it's going to have this set on by default, which don't ask me why. It's not a very good idea, but it is a thing that you will inevitably face if you've downloaded Unreal for the first time. And all that's happening here, it's actually, if you go to edit and then the project settings, at the top of the screen, type in mobile, you'll see this setting that says always show touch interface. And this is the touch interface. It's the joysticks for when you're on a mobile device. So for some reason that's set to true. So just deselect that. Now when you stop playing and play your game again, it will go away. That is one problem solved. But because we're using Unreal for visual effects and we're not really using it to create a game, if we click these 3 dots on the right here, by default that play button will just play the selected viewport, meaning it will start game mode for the selected viewport. But what we can do instead is hit simulate, because this is more accurately what Movie Render Queue is going to do when we render out our sequences. And Movie Render Queue is just the rendering system that we're going to use to render everything out of Unreal. So if you're using Unreal for visual effects, you'll want to always simulate. There's really no reason to play your game. And when you're in simulation mode, you still have controls over everything in your scene. So you can still move things around. You're not forced into the WASD controls that you are when you're in game mode. One thing you'll notice when you're in simulation mode, and let's say you have your decals and you're moving those around and finessing them, and you move that over here. As soon as I press stop simulation, everything's going to pop back to where it originally started. If you ever want to keep your simulation changes, let's press simulate here. Let's say I move our BP over here, and it's still called ceiling tiles. We will create ceiling tiles, don't worry. But now we've moved him forward. If we wanted to keep that change for whatever reason, just find that actor in your outliner, right-click it, and you're going to go to the bottom and press Keep Simulation Changes. The hotkey is also K, and we can keep simulation changes that way. All right, so before proceeding, I'm going to take our light source. I'm going to uncheck Effects World. So now we are in our dark. And just so you understand what these events are doing, so event begin play is just whenever we press play or press simulate, it's going to run this event. So a good debug thing is just to type in print string. So now that I have this, I'm just going to compile our blueprint. And when I press simulate, all that's going to happen is it's going to print hello. So we have event begin play. We also have event tick. So event tick just means every frame that's rendered means one tick has occurred. So now if I press simulate, you'll see we'll get a ton of hellos for every single frame that's rendered. And we can press stop here. So there's more that we'll do with this. I just wanted to introduce the concepts of what's going on with blueprints so that we can start creating our ceiling blueprint. So now let's use blueprints to take our cube actor and create many instances of it and create a grid of cubes across our entire ceiling. All right, so I'm going to clear everything out of our blueprints, and we'll delete everything in the construction script to make sure our event graph is also empty. Cool. So like I was saying before, we can just add any static mesh, and a static mesh is just the name for any individual mesh in our scene. So in this case, we'll call this ceiling tile underscore static mesh. We just brought in a static mesh, so now we have to define it as the static mesh that we want. So now we can click this cube in our scene, and then if we click the browse icon, underneath our blueprint here, it's selected the cube, and now we can click use selected mesh, and we'll do the same thing with the material, hit browse to that material, and hit use that material. Cool. And now if we look at our viewport, we have our static mesh. If we compile it, we now have a second mesh over here, which is great. And let's bring this into our construction script. So now we have our one static mesh here, but if we want to instance many static meshes, all we have to do is instead of using a static mesh, we can just type in instance, and we can see that there's an instanced static mesh option, and I'll call this ceiling tile instance. And it came in as a child to that actor. We don't want that, but we do want to keep this default scene root. So if I bring this and drag it on top of default scene root, It'll ask us, do we want to make it our new root, which we don't want to do, or do we want to attach it as a child underneath it? So we're going to attach it. And now our new instance, we don't have a static mesh assigned, so let's do the same thing and assign it the same static mesh and the same material. So now we can delete our original static mesh because we don't need it anymore. But there is something specific that we have to do with instance static meshes to make them show up in our blueprint. And I'm going to show you how to do that right now. So the specific thing that we need to do in our construction script, we need to type in add instance. So we need to create a new instance of that static mesh. So I'll type in add instance, and if we compile it, we get an error, and it's because we don't have a transform for this instance. But if we take our ceiling tile instance and let's get the transform, so we just want to grab that data. Now, again, there are so many options because it's basically giving you every piece of data you can possibly grab from this instance. So it can be confusing at first. In this case, all we want to look for is get relative transform. Typically, you're going to look for the relative transform or the world transform. But in this case, we want relative. And let's just plug that into the transform there. And when we hit compile, now we've actually created a new instance in our scene in the construction graph. But the next question is, now we've added one instance, how can we add a grid of instances? So to do that, we're going to have to add several in a row. And a good way to do that is by creating a loop, in this case, a for loop. So let's just type in for loop, not for each loop. So the easiest way to understand a for loop is we have this execution pin, the construction script is executing, and as soon as you have a for loop, it's going to continue executing this loop body over and over and over again based on these indexes here. So between the first index and the last index. So if I set this to 1, it's going to execute this 10 times over and over and over again every single time that construction script is run. So this doesn't do anything at first because I'm saying, hey, let's get the relative transform, but that transform is in the same exact spot. So all I've done is I've added 10 cubes in the same exact spot, so it doesn't look any different. But what if every time we run that loop, we could say, hey, move one more cube length away. And after we execute that loop, add another cube length and another cube length and another cube length until we've hit a set number of cubes. So here's how we can do that. So we're going to change how we set up this transform. So one thing I'm going to do, I'm actually going to right click and type in make transform. So if you look at all these data types that we have here, we can make any of these. So vectors, for example, like we saw in the material graph, are just 3 float variables jammed into one piece of data, now known as a vector. So if I right click down here and type in make vector, we'll see, okay, we would have 3 individual floats, and that makes a vector. And you can see that this location is a vector, and so is scale. So if you have a location, a rotation, and a scale, that has now made a transform piece of data. So again, all that we're trying to do is we're trying to take data and feed it into Unreal in a way that it'll understand. And this can take a little bit of time to get used to because this is really us learning that programming language, and it is a language for the first time if you're new to programming especially. But a way that Unreal tries to help us with that is if you hover over any of these pins, you can see the type of data that it's expecting to give or receive. So in this case, it will give a transform data, and we know that because we typed in make transform. But if we look here at the location, it's saying, hey, we want a vector. At scale, we want a vector, and rotation, it wants a rotator, which is also a vector. We can just type that in, make rotator, but it's just a specific value used for rotation. All right, so let's unplug all of these. We have our make transform. Let's plug this into our world transform. And we have our ceiling tile. So one thing we can do to find out how big this is in units, we can type in get local bounds. So this will grab the bounding box or the amount of space that this takes up. Now I'm going to do, this is going to give us the true bounding box in a single vector here. So now we have the cube length, and now every time we run a for loop, we want to place another cube exactly where that last cube left off. And so each loop we want to add another cube, and another cube. So during a for loop, one piece of data that we get out of that loop is what index are we currently on. So we run it for the first time, we get 1. We run it for the second time, we get 2. We run it for the third time, we get 3. So we can do that and multiply that by our bounding box to say, hey, it needs to be 1 cube length away. This one needs to be 2 cube lengths away. This needs to be 3 cube lengths away. So I'm going to take this, I'm just going to multiply it by our local bounds, and now we're going to tie that in to our location. And now we'd expect it to start at 0, run 10 loops to get to the end, and hit compile. And now when we look at this, now we have a bunch of cubes in our scene, but they're going up and to the right. So this is a great start. We're at least getting somewhere. We're instancing all these cubes, but why is it going up and to the right in this direction instead of a long single row? Well, it's because we have a mismatch in the data that we're sending and receiving in Unreal. So what's happening here, we're getting this local bounds, but if you look at this, it's a yellow color. It's not green. Green is a float value. Yellow is a vector, meaning X, Y, and Z. So our transform data, our location data here is in X, Y, and Z. So what's happening here is we're getting the bounds in X, Y, and Z. We're multiplying it by that integer, which is why we're getting these copies, but we're increasing our transform data in X and Y and Z. So we're adding X, Y, and Z every time, which is why it's in this diagonal, which actually makes perfect sense if you think about it. So we definitely don't want it going up in Z. So if we remove the pin here, and to do that, you just control click that pin off so that you can remove it. So whenever you have vectors, if you right click the pin here, you can type split struct pin. And this will split our vector into 3 float values. And now we have X, Y, and Z separated. So we can keep Z at 0 because we never want to change Z. For now, we can keep Y set to 0. But we also need to make sure that this bounds is split in X, Y, Z. So let's split this struct pin. Now our multiply is still going to be in vector mode. So we can change this by right-clicking the pin we want to change. We could just change this to a float. And now if we look at our cube, we can see that the X bounds is the one that will move it to the right here. So let's grab the X, multiply that by the integer, change this to a float, and set our location X to that value. And now let's see what happens when we compile. And sweet, there we go. Now we have a perfect row of cubes that will exist in our scene. We can see that we get that nice reflection off of them from our decal on the ground. And now we're on our way to create that perfect row of grids that we were looking for from our ceiling here. So let's keep going. Earlier, I talked about adding in variables. So we have components, which components are actors, but we can also use variables that are just pure data. They're not associated to an actor or something that we're placing in our scene. It's just data itself that we're going to modify. So we should make a rows and we should make a columns. So if we change row to integer instead of float, that'll give us a whole number because we can't really have half of a row. We want whole numbers. And if we click these little eye icons to the left here, then our rows and columns will show up inside of the details panel of our blueprint. So I was looking at this earlier. It's going to be 20 cubes across. So if we have our rows here, if we scroll down, we can set the default value to 20. So we'll set that to 20. And then we'll set the columns to 40 because we want that to be twice as long into the distance. And now what we can do with our rows is we can drag this in. We're just getting that row data. Again, get or set. In this case, we want to get the reference to that data. We'll set that to the last index. And now when we hit compile, this should be longer and we'll have 20 rows of cubes, which is looking cool. And again, like if we drag this around, this will dynamically change how many cubes are in our row. And every time we're modifying this actor, either by moving it or changing the row or column data, it is running that construction script again. So it happens automatically. You don't have to really think about it. And now to just make this a proper ceiling, I'm just going to move this up above his head and kind of intersecting here. So now we just have to make another row of columns so it goes out into the distance. So the easiest way to do that is to make another for loop using very similar ideas and techniques, and we're just going to take it one step further. So I'm going to just copy and paste this. Let's make another for loop. In this case, the last index, instead of using the rows, I'm going to add the columns. So let's get the reference to our columns, and we'll set that there. And we'll set the loop body to add instance. Again, if we look at our gizmo, the gizmo never lies. Now we want to add, it's a little hard to tell that it's green, but we can tell that one's red. So this one's green. We want to add in the Y axis. So same idea. We're just going to take this multiply. We're going to grab our Y bounds. We're going to take the index of our columns for loop, and we're going to plug that into the location Y. And now if we press compile, now we just made a huge grid of cubes. So I'm going to rotate this around and get this into place. And now, as you can see, we have our bat cave fully assembled. So it's matching our reference and it's looking pretty sweet. So the one thing that you'll notice immediately if you look close to this guy is he has this odd black shadow clouding behind him. And this is because now that we've created this entire box using these emissive materials, our scene is lit entirely with lumen. And honestly, this is something that you don't want to do. You don't want to use lumen to drive all of the lighting inside of your scene because there is some artifacting. Lumen adds nice GI bounce into your scene. It's nice as supplementary lighting, but it's not good as the key light or the source of all of the lighting in your scene for many reasons. But the main one is that it's based off of screen space, which means if I move my camera really quickly, we'll start to get artifacting around the edges. And if I look over here, the edge starts to get really dark, but as I start to look at it, it will get brighter. So in order to avoid this, you would want to start to use some rectangle lights in your scene because these mimic the same size and shape of these top grids that we have. Unfortunately, just because this entire scene is lit with lumen, it's not going to completely fix everything, but you can see that the holes that we have in the back here that are caused by lumen artifacting can be solved by placing lights back here. Now you'd have to place lights throughout your entire scene. So this whole exercise was to show you what the limitations of lumen are, because there are a lot of great things you can do with lumen. There aren't many restrictions, but this is one of them, and I think it's worth just showing early on so you kind of know the restrictions to not light everything with emissive materials. You want to use lights the proper way, and we'll get into all those different lights in the next chapter. So just remember, don't rely on lumen or emissive objects inside your scene exclusively. You want to use proper lights in the lights drop down here. All right, so that is our first basic environment out of the way. Hopefully this has made blueprints a little bit more accessible and understandable, especially if this is your first entry into programming ever. The few things to remember are blueprints are just about sending and receiving data. We store data through the components or the sub-actors within our blueprint, or creating variables, which we can then use to modify data through events and execution strings, which will be used in construction events and events themselves in the event graph. We learned a little bit about materials, the PBR workflows that go into all of the materials inside of Unreal, a little bit about tiling and decals, and how we can modify material instances to make creative changes, whether that's in the albedo channel, the normal intensity, or the amount of roughness or glossiness that exists on each of our materials. And this should prepare us for our next scene that we're going to create, which is this cave tunnel from the movie Raya and the Last Dragon, where we'll talk about lighting, creating our own materials and displacements based off of Quixel materials. And we'll get our first character in our scene and set up a camera so we can render something through Movie Render Queue and Sequencer. All right, welcome to chapter 3. And in this section, we're going to embrace the game engine side of Unreal and build our first game. We're going to keep it really simple, and we're going to build on top of our third-person example project. So if you weren't following along earlier, to add this in the content browser, you just press the add button, add a feature or content pack, and then just add this third-person project into your folder. And why we're going to build our own game is because in order to learn Unreal effectively, we have to know how we're supposed to use Unreal to create games in the first place and answer the question of what happens when we press the play button. So when we're in this level, we have this new controller. We have our Manny controller here where we can walk around and we can use our mouse to move around the world, and we can use space to jump. And these little cubes we can run into, and they'll have their own physics simulations and collision, so we can jump on top of them and jump onto other objects in our scene. And if I press escape, we'll jump out of game mode exactly where our character was. But if I search for our mannequin in the outliner, it doesn't show up. So how do we tell Unreal what to do when we press play so that we can control characters or decide not to control characters? Well, if you click on this little blueprint graph up here, you'll see that we have something called a game mode. And if I just edit this game mode to see what's going on inside of it, you'll see that it gives us a list of data. Now, this is a data-only blueprint, so there's no viewport attached to this blueprint. And this is just setting some defaults inside of our game. And the one that matters here, what brought that character into our scene, is the default pawn class, and that's set to BP third-person character. Now, what is a pawn? A pawn is any character that can be controlled. So as the player of the game, you can control a pawn. A vehicle would be a pawn. Any character that can be controlled is a pawn. So your enemies would be pawns. So use AI so that game logic is controlling pawns. And a pawn is just a blueprint. So if I created a new blueprint class, you'll see that the second most common type of blueprint is a pawn that we can possess and receive input from a controller. And like I said, because this character is set as our default pawn class, when we press play, that pawn is going to be created. And now this actor is going to be placed wherever our player start actor exists inside of our scene. So if I went to this quick add actors menu and I just typed in player start, it's just a type of actor that you can drag in. You'll want to have just one. And if you look in the details panel of this player start, you'll see that we can't select an actor here. It's automatically set up where we'll grab the pawn of our game mode. One thing you should know though is that this can be overwritten. If I go to window and I type in world settings, this is the one other place where you can override the game mode settings of whatever map you're inside of. This will be kind of hidden, especially if you're opening up other projects, other games from the marketplace using this menu. Now, based on whatever game mode we select here, that will auto-populate these default classes for you. But you can see this matches what we had before. The default pawn class is set to BP third-person character. And that's why when we press play, our character spawns and we can jump around and play as our character. So now, as an example, if I jump back to our starting level, what happens when I press play here? In this case, I have to click on the screen and I can now pilot around, but there's no pawn that I'm controlling by default. It just creates a camera, and we can see why is because if I look here in our project settings, there's no game mode selected. So in this case, if I added the third person game mode into this world, and now if I add a player start actor into our scene and press play, we'll be playing our third person game mode. Now, one last way to do this, if I unselect this game mode, I'll set the game mode base class to none, and I'll remove our player start. So if I drag in this third person character into our scene, one thing we can do, if I select my player here and we search for auto possess player, right now it's disabled. So when I press play, I just have a camera inside of our scene. But if I change auto possess player to player 0 and then press play, you'll see that now we are controlling this character. And obviously it makes sense as to why. Player 0 is us in the world. So if you ever have a character that when you press play, you're immediately snapping to their controls, it's because that auto possess player is on. Now you can turn this off. But sometimes this is helpful if you just want to drag this third person character into your scene and run around without messing with the game settings. You can just drag and drop the pawn into your scene and set auto possess player to 0. So let's jump back to our third person map and let's make a duplicate of it here because we're going to edit this and we're going to create our own simple game and show you a little bit more in depth how blueprints and objects work together to create games. So we'll call this third person map 02 and let's jump inside. And the first thing I want to talk about inside of our game are the physics assets. So when I run around and I hit these blue boxes, we can see they bounce around, but they still work as objects that I can jump onto as a character. So how is that set up? So if I look closer at these blue boxes, The one checkbox that's enabling this, if you scroll down, is under physics, and we're simulating physics. So by default, objects don't have this enabled, and this only works if your object is a movable object. So some objects, if you know this wall is never going to move, it makes sense to set it to a static object. And what that does is it tells Unreal that, hey, we don't ever need to worry about the moving capabilities of this object ever. I'm going to disable a bunch of settings because I know it's never going to move. But some objects we want to move, we want them to interact and bounce around and get these physics simulations. So we've set the physics, we can give them mass. Gravity has to be enabled, but it is enabled by default once you simulate physics. So the physics settings are what allow us to hit this object and have it bounce around our scene. But the way that it collides with our character is under the collision options right underneath physics. And right now, most of what you need to know is going to be under this collisions presets. This physics actor preset allows us to bounce around and walk on top of these objects. So I'm going to set this to block all dynamic, and then I'm going to disable simulate physics. And now when I run into this cube over here, it will block our character, so we're not able to pass through it, but then we could also jump on top of it. And if I want to disable collision, I would just change this preset to no collision. But for now, I'm going to set it back to physics actor. But the way that Unreal is going to handle all of those physics collisions and interactions are through low-res collision meshes. So if I enable this by pressing Alt-C or going to show collision, I can see the collision for all of the different boxes inside of our scene. And this is what determines what our characters can walk on, what they can land on, and how these objects will interact as they're flung around the scene. And you can see that they're not always matching one-to-one. For this edge, it's approximated by this box. But if I wanted to change or modify the collision for any object, I would just select it in our viewport and press Control-E. And this is going to open up whatever you select, whether it's a static mesh or a blueprint. In this case, it's just a static mesh. And at the top, there's a tab for collision. And here we can remove the collision if we wanted to. And now you can see our box has disappeared here. And now we could regenerate it by going to Auto Convex Collision and hitting Apply. And now this may be hard to see, but now it's made a really tight collision object. It's now looking like this red line here. That's what the new collision object is. So now if I wanted to play our game and interact, it's going to be a lot more accurate as it slides around. So if you're trying to get really accurate physics simulations when you're having interactable objects inside of your scene, then you can always go back and regenerate a new collision mesh for your objects. Just try to keep them as simple as possible so that way you can have as many physics objects inside of one single scene and they'll all run smoothly together. Now I want to make some blueprints and build out a really simple game so that you have a clear understanding of how Unreal would be used for games. And just like we were talking about before, this is all about sending and receiving, setting and getting data from one object to another. That's all we're going to be setting up in this next example. So let's say we want to start collecting these green rubies, these green diamonds. So let's collect 5 of these and we'll keep score. We'll have a little pop-up in the corner so that we know how many we've collected. And then once we collect 5 of these diamonds, we'll turn our jump into a super jump. And that'll let us jump on top of this box here, because normally we'd have to jump onto one box and onto another just to get up. But we have this object in our scene, and when I run into it, we can see physics are enabled, but we're going to want something that we walk through it and then it disappears and then we get a score counter popping up in the corner. So how can we set something like that up? So I'm going to add this right into the third person blueprint folder. So I'm going to create a new blueprint and I'm going to call it BP underscore gem pickup. And let's open up this blueprint and we're going to create these green diamonds. So I'm going to create a new component in this blueprint. I'm going to search for static mesh, and you can see we have that option here. I'll call this gem, and on the right side, I'm going to search for a static mesh in my scene. I'm just going to search for diamond, and you'll see this control rig diamond, so let me click on that. And then I'm going to use this blue texture, so I'm going to browse to this blue texture, and then I just made a duplicate and made it green, and I'm going to apply that green texture to this blueprint. And now let me press save. And now I'm going to drag and drop this blueprint into our scene and lift it off the ground. But right now, all this is a static mesh floating in the air. So if I press play, and I ran into it, it would just block us from moving forward. So we want to run through this, collect it, have it disappear once we run through it, and give us a little score. So how can we do that? Well, the first thing we'll want to set up is the collision detection. So let's add a new component, and we'll type in sphere, and you can see there's this sphere collision. So if instead I typed in collision, you'll see we have 3 different types: box, capsule, and sphere collision. In this case, we'll make a sphere. And let's change the sphere radius to be a lot bigger so that if we get close to our object, if we get inside the bounds of this sphere, we'll consider it collected. So now that I have the sphere collision selected, at the very bottom, there's a couple events that we can generate based on the collision and overlap settings. So if I press on this add button next to on component begin overlap, this will then pop open the event graph and it'll show a new event has been created on component begin overlap. So whenever any object overlaps this sphere collision, this event will execute. So we can add in some more execution nodes after this. So let's create a print node by typing in print string. And now if we ever overlap this sphere, we should get a little pop-up saying hello on the top left of our screen. So let's press play and let's run up to this. And you can see on the top left, now we can see hello. And if we go back, every single time we run into this, there's a little bit of a countdown for how long that hello will last in the corner, but we can just continue pressing that. But how can I make it so I can just pick this up once and then never collide with it again? Well, if I go back to the blueprint, one thing I can do after this print string is just create a destroy actor node. And what it will do is it will destroy the target, which is itself. So now if I play our game again, I'll run through this, it'll delete and it'll say hello. And now when I run through that same area, that collision is now completely gone. So there's no way for us to overlap with it anymore. So cool, that gets us close. Now this print string node is really helpful for debugging, but in this case, we're just gonna make a simple coin counter and we'll just say you have 1 coin here. But now if I was going to duplicate this blueprint across our scene, so I'll put 3 in a row here and we run through them, it'll say you have 1 coin over and over again. But what if we wanted that to increase? Now we do have a problem here by using this method, is that once we destroy this object, it no longer exists in our scene. It's not even going to be in our outliner anymore. It's just completely destroyed. And like I said, Unreal is all about sending and receiving data. So one way we can keep score is not by storing that data inside of these gem pickup blueprints, which we know are going to be destroyed. We can store it inside of our player character. So instead of modifying our gems, we can modify our character blueprint. So to modify any blueprint, if you have it selected in your scene, you can press Control and E, that's the hotkey, to just open up whatever editor that object is. And so now if we want to keep score inside of this character, we're going to need to add that new data as a variable. So let's just create a new variable called score, and we'll make this an integer, which is just a whole number, so no decimal points. And we'll have it set to 0 by default. Now let's save this and compile our blueprint character. But now we need some way for our blueprint character, when it destroys this new gemstone, we need some way for this gemstone to send some data back to our mannequin to know that our score has been updated. So how would we do that? So we need to somehow create a reference of this character blueprint inside of our gem pickup. And the way we can do that is by something called casting. So if I pull on this execution node and I just type in cast, I can cast to any single object inside of my entire project file after typing in cast here. So if I type in cast and then third person, you'll see it gives options for everything titled third person in our entire project. And I want to cast to our BP third person character. Now, what exactly is casting? Casting is just a way for us to reference the data of another object, but now we can do it locally inside of another blueprint. So if I pull on this execution string, suddenly I have access to all of the data inside of this mannequin blueprint. And now I can get any data from this blueprint, or I can set the data inside of this blueprint. So just as a pure example, I'm going to set the visibility of the mesh inside of it. and make the new visibility 0. So now if I just plug the execution pins in so that this entire node graph executes and compile this, I'm just going to plug our other actor input into the object here. All right, so now if I press play and I run into any of our sphere collisions and create that overlap event, you can see now my character has turned invisible. And now if I press Shift F1, that'll give me my cursor back so I can move around in my outliner and manipulate the scene that way while game mode is still running. And now if I search for third person character, you can see we have 2 in our scene. The yellow is the one that's been spawned now that we're in game mode. And I'll have to click on the component inside of this blueprint. So I'll click on the mesh here and I click on the rendering tab. I can see that that visibility has been turned off. And now if I turn that back on, I just forced it to be on again. And then I'm going to click inside of my viewport again. Now my control is back. The next time I overlap with that actor, you can see that that visibility has been turned off again. So now we know that we're successfully communicating between these 2 blueprints. The code inside of this gemstone is manipulating our player. We're just setting the data of an actor based on an event that has been triggered. But now let's set up a way to keep score. So now I'm going to expand this gemstone blueprint and let's look inside of the event graph. I'm going to delete our visibility toggle. And instead, I want to access that new piece of data that we've created called score. So if I pull off of this cast node as the BP third person character and I type in get score, you can see that this piece of data is now accessible inside of our gem pickup. And now I want to set that score. So I'm going to pull that off and type in set score. In this way, I can set that data inside of our blueprint. So this will directly manipulate that data. And what I want to do is I want to take whatever the current score is and just add 1 on top of it every time we overlap this sphere. So I'm going to pull off of our score node and make an add node. And I'm just going to add 1 integer to that. And then let's print our score. So I'm going to pull off of our string. You can append several strings together. So what I can do here in the A input, I'm going to type in your score is. The B input, I'm just going to plug in that score variable. And then this is just going to create a node where it'll transform that integer data into a piece of string data. So now when I run through our gems here, now when I play the game and I walk through this, my score is set to 1, 2, and 3. So now that's working together correctly. And when I run through here, the objects have been destroyed and there's no more overlap events happening. Now this is a basic example, but this really is the fundamentals of how this works. The one last thing we haven't done, we've affected the data inside of our BP third person character. But what if we wanted to trigger an event inside of this third person character event graph? So we're not just manipulating data, we actually trigger some execution pins inside of another node. So to do that, I'm going to go into the third person character blueprint graph, and I'm going to right click inside of that event graph, and I'm going to type in custom event, and this will let us add in a brand new custom event, and we'll call this score check. So let's say we wanted to print you win once we get to 5 coins. Just as a really simple example that we can trigger with this event, let's create a print node and the string will be you win. But we only want to trigger this when our score hits 5. So I'm going to drag that score data into the scene. I'm going to get it. Now we have a reference to this piece of data. And if I wanted to test whether something is greater than or equal to 5, I could type in the greater than sign, and you see we get 2 operations, 2 math nodes here. We can have a greater or equal to node. And if you hover over this, you can see that this returns true if A is greater or equal to whatever we put into the B input. So if I set this to 5, that means that this will only be true once score is greater than or equal to 5. But this Boolean data, this red pin that you're seeing here, and I know this because I'm highlighting it and I see Boolean, this piece of data really does not work with the string itself. So we would actually need to create a logic node. So there's a node called branch, which can take a Boolean input. So let me plug this into our branch. And if this is true, if this condition is true, it will print you win. But if it's false, nothing will happen. And then to trigger this event inside of our gem blueprint, let's just follow the flow here. On component begin overlap, we're going to cast to the third person character. So we're going to get data from that. We're getting the score. We're adding one to that score, printing out what the current score is. We're going to destroy the actor. And then after this, let's trigger that event from our third person character. So this event is called score check. So if I just right click in this event graph and type in score check, you'll see nothing comes up. Now, why is that? It's because we still need to pull off of this data pin so that we have all of the data associated with this BP third person character. But if I pull off of this pin and now I type in score check, you can see it gives us the ability to use the score check event. And now if I put this at the end and connect the execution pins, and now let me compile both of our blueprints here. Let's just add 2 more gemstones to pick up. And now we'll have our character run through 1, 2, 3, 4, 5, and you win. And that you win is being printed from our third person character. Look, she's happy. So yeah, that's exactly how we can take data, manipulate it, and then also talk between the different actors and different blueprints inside of our scene by sending and receiving data and events. But the last thing that we wanted to add was once we hit a score of 5, we wanted to increase our jump so that we could make this jump onto these taller surfaces. So how could we do that? So now if I open up this BP third person character, the way that locomotion and moving around is set up with this character is all controlled within this character movement component. Now, whenever you see this edit in C++ next to any component here, it means that it's not something that was created using blueprints. It was a custom C++ component, and it means there's some additional code going on under the hood, which for character locomotion can be nice because they've included just a ton of settings here. But usually we can still access any of these pieces of data. So if I scroll down, you can see that the character movement jumping and falling setting is set to 700 centimeters per second. So if we wanted to increase our jump here, what we could do is jump into the event graph of our third person character. And at the end of our score check event, we can change that jump Z velocity. And let's walk through how you would think of modifying this. So far, you'd probably think that we pull on this execution pin and then we would type in jump Z velocity, but we don't see anything in this dropdown. And that's because all of this data is actually in this separate component, this character movement component. So we would actually have to reference this movement component if we want to access or change this data. But all I have to do is drag this into our scene. And now suddenly, in the same way that we could access all the data from that casting pin, now we can access all of the character movement data from this pin. So now if I type in jump Z velocity, now we can get that jump Z velocity, or we could type in set jump Z velocity. And now if we set this to 1000 instead of 700 like it was before, and then we play our game. So here you can see our jump is really short, but after we collect our 5 gemstones, we can now jump up to the very top of these surfaces, and we've successfully changed our jump height. And as a reminder, all of those execution pins that we were using, these can only be triggered when we're either simulating or playing our game. And I should say the only difference between playing a game and simulating is that when you simulate, you're not possessing a pawn. So we're still playing our game. The physics simulation is running here, but we're not controlling a pawn. That's the only difference here. So now you've made your own very simplified game. All of the building blocks are there. And I hope now you have a very clear understanding of how we can send data between all these nodes, especially between blueprints. All right, so now it's your turn to add on top of this. Here's your assignment to do on your own. I want you to add orange gems into your scene, a new blueprint that will create a speed upgrade. Have your upgrades, the jump and the speed upgrade, disable after 5 seconds. So it only lasts for 5 seconds in total. And after collecting 10 gems, have a door open up inside of this map that opens to another section for level 2. So the easiest way to do that is just copy these walls into another section. And after a score of 10 has been reached, we can open up a slot in between these 2 sections and open up into our second level. Now, this should be fairly straightforward, but I want you to try to apply these concepts, not just understand them, but actually try to engineer solutions to your own problems, which is the whole point of blueprints and the blueprint event graph. So try things out, play your game to make sure that everything is working correctly. And don't be afraid to search through this massive list. Again, we're going to get and set most of our data. And if you're ever stuck, just look at these drop downs like add event will give us more events. And you can go under utilities and then flow control. And this will give you the logic, different ways to split off your execution pins in different ways, create for loops like we were doing earlier, or create delays. But that's it. Good luck, and I'll see you in the next video. Welcome to our next chapter. This entire chapter is going to be focused entirely on creating photorealistic environments. Before, we were still getting our feet wet with how we can use the different tools inside of Unreal, but now we're going to start looking at photorealism and creating cinematic lighting and environments by referencing this still from Raya in The Last Dragon. I think there's a lot of really great high detail geometry on these walls and ground here that we can use the modeling tools to create 3D displacement meshes for, which is a great technique to leverage Nanite, the ability to use as many polygons as we want inside of Unreal Engine. So we're gonna block out the scene, figure out how to render this out through Movie Render Queue so we can make progress renders throughout the entire time we're making it, and then work on lighting, volumetric fog, and lastly, add in these torch effects with flickering lights and loopable animations. And I'll show you step by step the best way to make effects elements like this inside of Unreal. So before we move on, make sure you have the modeling tools plugin enabled. It's really important for this lesson. And before we move on, we're gonna wanna download Echo. So this is the character you may have seen in all of the really great Unreal 5 demos. And if you go to the Unreal Marketplace through the Epic Games Launcher and you just type in Echo, you'll see that we can actually download Windwalker Echo, which is complete with a groom, control rig, and physics interaction. And we're going to use this example to learn the entire character pipeline inside of Unreal. So go ahead and download this project, and you'll have to create a new project. Unfortunately, this is only supported in the old engine versions, so I've imported her into our project file if you're following along there. Otherwise, you can download a previous engine version and create a project, open up the file there, and simply migrate Echo into your latest project file. And to get started with creating our map, one thing that I really like to do is if you go to your all folder, which is one level above your content folder, you'll see that we also have this engine folder. Now, if you don't see this, you'll need to make sure that show engine content is enabled here in your content browser settings. But once you do that, you can double click on engine and then make a level filter, which you can set up by clicking here and then selecting level. And now we can see all of the different levels that come with the engine by default. Now, now I'm looking at this time of day default map. And if we really like this and want to start from here, I could just click and drag this time of day default into our UEVFX levels and Raya 01 folder. So let me copy that here. And now in the Raya 01 folder, I can just rename this to ML_Raya 01 and open that up. And now we're starting inside of this map. The other way to start off a level, if I delete everything from inside the scene, would be by going to Window and then Environment Light Mixer. And then this Environment Light Mixer, if you just click all of these buttons at the top, will create a skylight, atmosphere light, sky atmosphere, fog, and volumetric cloud. This will create a sun and sky system for our scene. And then from here, we can just drag in a cube, reset our location, and then reset our scale to 20 by 20 and set our vertical scale to 0.5. And now we've created a really simple scene, which has everything we need to get started. So I've gone ahead and I've migrated the Echo content from that project folder. If you need to migrate this into Unreal 5.2, the only things I had to do was in the plugins menu was to enable these two plugins, the Groom plugin and the Alembic Groom importer. And underneath content, Echo content, blueprints, just drag in BP_Echo. Now this is a game controller, and because of that, nested inside of this blueprint is this spring arm and camera option. So if you want to go ahead, just duplicate BP_Echo and rename this to BP_Echo Sequencer and open this up. And we'll go ahead and delete the spring arm and camera. And just so you have a basic understanding with controllers, These have a specific type of event called input events. If you right click here and scroll down until you can find input, these are all the different types of input events that we can have. The most common one, if you want to quickly debug something in your blueprint, is under this keyboard events dropdown. And here you can have any key on your keyboard create an event. So if I just grab the one key here, this pin will execute as soon as the one key is pressed while your game is playing or when it's released. All right, so we'll delete that, save our asset, and let's add in our new BP Echo sequencer into our scene. And now we have our scale reference. So with our default settings here, our scene is really bright. The floor itself is clipping white. And if you imagine seeing this shadow outside, for it to be this bright, that would mean the sunlight would have to be blasting in our scene. So something you'll need to add into every one of your projects is a post-process volume. So we can just drag this into our scene, and let's make sure we keep this in our lighting level. And this post-process volume is going to be the render settings inside of our scene. So the first thing you want to do every single time is type in infinite for infinite extent. The way this is set up by default is that you'll only see what's happening when your camera is inside of this volume, but we want to have one actor that controls the entire scene regardless of where our camera is. So we're going to check this so that it's set to true. And this has different settings like color grading settings, depth of field, lens flares, but the first thing you'll typically want to adjust is the exposure settings. So by default, our camera is set to have auto exposure. And I like to treat our viewport like it's a real camera. So I like to set this to manual. And our default settings are going to make this go very dark at first. And I like to have a couple of magic numbers, just some constant numbers that you should go back to typically when starting up your scene. So if there's one magic number to remember in terms of exposure compensation, we'll want to set this to 10 by default. Something really important to note here, if you go into our view modes and go all the way to the bottom, you'll see we have this exposure setting here. And you want to make sure your game setting is set to true. This will make sure that our post-process volume is what we're seeing inside of our scene. If I uncheck this, I can change this EV100 setting to compensate brighter or darker, which can help us adjust the exposure on the fly and not change our overall settings. But you'll want to set this back to 0 and make sure you have game settings set to true so that we know exactly what our scene should look like. And just so we get an accurate view of our scene, this basic shape material is set to a pure white, and snow actually isn't even this bright. So if you type in here and just search for world, there'll be some default world grid materials that we can set this to, which will make sure our bounce light is a bit more accurate and true to real life. All right, so now let's try to block out our scene and have a brief introduction into the modeling tools. So let's activate modeling mode. If you don't see this, you'll have to go to your plugins folder and type in modeling. And this has this modeling tools editor mode. This is in beta, but this is one of the steps that Epic is taking to have everything created inside of the engine. You can go back and forth between another DCC like Maya or Blender or Houdini, but I think Unreal is at its most powerful when you're never leaving the engine. And it also has some really fast and high quality displacement tools. So let's learn about the modeling mode inside of Unreal. So starting off, we have these different primitive shapes. This is the scene that we'll have to block out. So at first, let's just make a curved tunnel without any of this high-res geometry detail. So we can go over here and create a new cylinder object. And this will create a cylinder wherever our mouse is, and it'll snap to our surfaces. So let's just click next to Echo here. And we can tell right away that we'll have to increase our radius. And then let's rotate this on our green y-axis. And let's roughly get this into place so we can tell how big this needs to be. And I think for our scene, this is based off of a cartoon, and this is Raya as a young girl. So we're going to change the proportions of how big our character is going to be in the scene. But I think setting this to 200 by default, it will give us a good start. Now, because we're rotated here, we'll probably want to increase our height. So let's go from 200 to 1,000 units. And it's just a block out, so we don't need a ton of resolution out of this cylinder, but we can see the faceting of the polygons here. So let's just double our radial slices to 32. And let's press accept. And now this will create a new cylinder in our scene. So you can see here it's created a new custom mesh. If we click the Browse to Cylinder icon here, we'll see exactly where this is, and it'll be created in this generated folder. So this is fine for now, but we'll want to migrate these into our assets folder once we're done. If you see the little star icon at the bottom left of the thumbnail there, this means that our object hasn't been saved. So if for some reason Unreal crashed right now, this file would be deleted and we couldn't restore it from our autosaves until it exists in the first place. So if you double click our actor here, this will open up the static mesh menu. And we'll just want to press save here so that we know this will still be here in case Unreal crashes. We'll talk more about the static mesh editor when we get into importing more Quixel assets, but the main things you'll be doing inside of the static mesh editor are adjusting your Nanite settings, assigning your default materials up here. We'll be using Nanite exclusively. These LOD settings were used primarily in Unreal 4 and earlier, and this would change the resolution of the geometry based on how far away you are from camera. But if you're using Nanite, know that these LOD settings aren't being used at all. You'll also have your light map resolution, which is used when baking your lights. We're using lumen and dynamic lights, so that's another thing that you won't have to worry about for now. The one thing you might use is looking at your UV channels, so this is a way to preview our UV maps. So we can close this. But now we need to make this into a tunnel, and the best way to do that would be duplicating our cylinder, reducing its size. So I'm going to scale it down in the red X and the green Y channel by dragging my mouse over the thin green and red line in between those two axes. I'm going to disable our scale snapping so we can just make it a bit smaller. And I'm going to scale this out in Z. And this is because we're going to do a simple Boolean operation where we'll use this cylinder to cut out the core of our original cylinder. So let's select our original cylinder and then select cylinder 2. And this will give us this mesh Boolean option. So let's click this. And this gives us a couple operations where we can use the volume of one mesh to cut out the volume of another. We can reverse this with our different operations here, but this is giving us the result we want, and we can press accept. So this has created a new static mesh. Something to know about the modeling toolset here is it can be very destructive, meaning that when you accept any operation, it can overwrite the previous mesh. And sometimes it's not possible to retrieve the old information. So if you're ever worried about this happening, don't be afraid to just duplicate any of these meshes so you have some extra copies. And again, every time you create a new mesh, it will not save it by default. So you'll have to go in and save the static mesh to make sure we don't lose it in case Unreal crashes. So this is great. We don't really need any of these other meshes anymore, so I'm just going to delete those so we can keep this folder clean. And now we have our first tunnel piece that we can use to block out our scene. Let's just add in a quick point light into our tunnel so we can see the light inside of it. So now that we have a really basic representation of our scene, let's create a camera so we can start previewing our shot and matching it to our reference one-to-one. So if I go back to our UE VFX folder and I go to sequences, let's create a new folder called Raya 01. And now let's create a new level sequence. So this exists under cinematics level sequence, and I'm going to type in ls_Raya01_blockout. Let me double click this to open it. And now this is our first timeline that we've created. Now Sequencer, like the static mesh editor or the skeletal mesh editor, is its own little plugin inside of Unreal. And this is where we'll spend a lot of time creating our sequences inside of Unreal. So a few things right off the bat, we want to change this from 30 frames per second to 24. We'll want to make sure this snapping is enabled by default. This will make sure that our time indicator is always on a whole frame. If we disable this, we'll see that there's a little asterisk that appears next to our frame count here. And now if I press the plus key to zoom into our timeline, you can see that I can drag the time indicator in between our frames. But now if I enable snapping or press the D key, that time indicator will snap to the nearest whole frame. This isn't that important early on, but this is a really good habit to build from the very beginning because we want to make sure that whatever we're seeing in our viewport is exactly what we'll receive when we render this out. So we can click this Create a New Camera button, and this will do a couple things right off the bat. It'll create a new Cinecamera actor into our scene, and it'll create a camera cut track. Now, if you press this button, you'll see our Cinecamera actor has this little lightning bolt icon next to it. And this means that it's only created when we have our sequencer open. So if I close this, you'll see that we no longer have a camera in our outliner, and we'll only get that back when we open up our sequencer. So this lightning bolt tells us that it's a spawnable actor, and I'm not a fan of having spawnable actors in a scene that we're creating for VFX because we want everything in our scene to exist at all times. This is mostly used for video games when you might want to spawn specific things just for the cinematic as it's playing, but it doesn't really serve any purpose when using Unreal for visual effects. So you can right-click any actor and convert it to possessable, and this will make sure that our Cinecamera actor exists even when we close Sequencer. Now, just so you're aware, I'm just going to delete this Cinecamera actor, and I'm going to delete the camera track. And if you ever wanted to create this from scratch, you just go to your Quick Add Actors button, go to Cinematics, and you can drag in a Cinecamera actor into your scene. Now to add this into Sequencer, we can either click and drag it into our timeline, and if it's the first camera in your level sequence, it'll automatically create a camera cut track. And now we're piloting our camera. So this little camera icon here next to our Cinecamera actor will lock this camera to our viewport, but it will also have us piloting this where we can now move our camera around, and now we can dial the camera position using the WASD controls. Now we have WASD to move around, but we also have the Q and the E buttons where Q will crane us down and E will crane up. And again, you can right click and press the mouse wheel to decrease our camera speeds so you can get really fine detail in where you want to position your camera. Now, if we get up close to Echo here, we can see that she's completely out of focus, and this is because by default, the manual focus distance is set to 1 million units away. So if I look at my Cinecamera actor here, let's scroll down in our details panel and go to the focus settings. And if we click on this Draw Debug Focus plane, this will show us where our focus is in the scene. Now, it's super far away, so I'm going to have to drag it to just a couple centimeters away to focus on Echo here. And we can see exactly where it intersects with her face, so we can fine-tune the focus point. But another thing we can do is change this focus method to tracking. And then we can select an actor that we can focus on dynamically. This way we can move around the scene, and we'll make sure that Echo is always in focus, and we don't have to manually tweak this as we move around and reframe our shots. We can also change the focal length, which is how far our lens is zoomed in or out. The best way to train your eye, period, about cameras and recreating real-life cameras and lenses inside a digital world is not to spend a bunch of time using CG, but it's to go outside with a real camera, with a DSLR, and see exactly how these lenses work. But if you've never done that before, again, one of those magic numbers is the widest lens you'll want to go is about 18. If you start to go more, it'll become extremely unrealistic, and you'll probably want to stay below 200 millimeters for a focal length. But looking back at our reference, I'm just going to guess here, but I'll say this is about a 35 millimeter lens. And now let's start to frame up our shot. So I'm using PureRef here. One thing that's really nice about PureRef is that you can set this to always on top mode. So I'll keep this up while I'm adjusting our 3D scene. We're going to have to end up curving our tunnel, but for now I'm just going to make a duplicate of our tunnel, and I'm just going to give it a slight rotation to mimic what's going on. We'll move that into place. And now let me grab another light, and we'll Alt click and drag this further down into our scene. And let's do the same for the floor plane. So let's drag this out and scale it up so that it intersects with our floor. And right here I can tell our gizmo is aligned with the world and not the rotation of this object. So I'm going to press our transform gizmo, the tilde key, and I'm going to Alt click and drag another copy in the same direction as our previous tunnel and give this another rotation and move this into place. Now I'm going to make another duplicate of the tunnel in the foreground, and now I need to pop out of camera view here. So I'm going to press this eject icon so I can start to move back in our scene, and I want to make sure that this also has a little bit of rotation, and I'll just adjust this here so it roughly lines up. Again, we're just trying to block out our scene here. Now, a really important thing about our camera here, I'm going to press this icon right next to our Cinecamera actor, and now we're piloting our camera again. But one thing that's really easy to do is accidentally right click inside of our scene, and now we've messed up the position of our camera. But unless you have a transform track here where it's actually taking note of the rotation and location of our camera, you won't always be able to undo this. So one thing that's helpful is once you're happy with where your camera is, you don't want to continue to pilot your camera with this camera icon. You want to view your camera cut instead. And when you view the camera cut, instead of piloting your actor, if you right click in this scene, you won't be able to move or rotate your camera around. So right now I'm right clicking inside of our scene, but I'm not able to rotate it or move it back and forth anymore. So this is really important to remember. Make sure to view the camera cut inside of your sequence instead of piloting your camera. So I think we're pretty good here. The one thing that's missing is I think we can move our camera backwards in the scene so we can see more of the foreground geometry, because once we add in this three-dimensional detail into our walls, we want to make sure to see that up close. So now I'm going to go back and pilot our camera, and I'm just going to move backwards in our scene. Awesome. I think this is pretty good for now. Let's just create a keyframe on our first frame here. So let's press this little plus icon, and it'll create a keyframe for us. And this will just make sure that we have data of where our camera is in case we ever move our camera accidentally and we need to undo it and return to this default position. So one tip that I have here, if you're trying to match the camera position, is figure out the height of the camera in the scene. And you can usually figure this out by seeing where the perspective lines change in the geometry. This is really easy when your scene is made out of boxes, like if you're looking down a city street, as opposed to a curved tunnel. But in this case, we can see the curvature of these different rocks here. And if you look at these individual bricks, you can see that they're going off in perspective like this. And at a certain point, they start to shift downwards. So at this point of equilibrium is roughly where our camera height is going to be. So I want the height of my camera to roughly be somewhere around this height. And if I look back in my scene here, I can just slowly start to crane up or down to see exactly where that equilibrium point is. So if I'm too high up, I can see that that perspective line, I'm too high up. And if I'm down here, I'm too low. And I just want to find that sweet spot where I'm somewhere in the middle here. Great. All right, so one topic that we haven't really talked about yet is the idea of UVs. So we need a way to apply a 2D texture to the 3D objects that are in our scene. And the way we do that is by taking the faces of our different objects and abstracting them into a 2D space through UV mapping. So everything that we've created in Unreal so far has relied on the entire surface of our cubes and planes to take up the entire UV map like we're seeing here. So we have a one-to-one relationship between every face of our object and our UV map. So tileable textures make this really easy, but typically the objects in our scene, even an object like a cube, would have a UV map where each face takes up a different spot on our UV map. Now, because this texture is tileable, I can move this texture around, and if everything roughly works, because we have a square object and these square tiles, but more complicated objects, like our Japanese stone statue here, will have individual UV islands that are laid out separately. So here, the different faces directly map onto sections on our UV space here. And if I were to drag this around, it'll immediately break our texture because it's expecting a specific UV map that our textures are based off of. And when we apply a tileable texture to this object, it doesn't have the same effect as our cube because the different UV islands are rotated and moved around in different areas. And the way these UV islands have been created don't allow for that one-to-one relationship. Now, if we go into Unreal in our static mesh editor here, we have this UV dropdown where we can see the UV channel for any object. But now let's look at how our UVs work within Unreal. So this is how all of our materials have been set up so far. We have our texture sample directly plugged into our emissive color, and this single plane takes up the entire UV map. Now the UVs can be visualized through the texture coordinate node. So if I plug this into our emissive color instead, now these red, green, and yellow colors are just data, and we can visualize what's going on here by making a component mask. Now if we look at our preview in the material editor here,
So imagine this image is a graph where on the bottom left we have 0 and at the top right we have 1. And this is our UV space where we go up in V and across in U, or we go up in Y and across in X, in the red and green channels of our image. So if I hide the green channel, so we're just looking at the red channel where we start at 0 and we go all the way to 1 on screen right. And now if I just show the green channel, you'll see the same thing. You can see we start at 0 on the bottom here, and as we go higher up, we reach 1 at the top. Now as we combine the red and the green channel, as they both start to reach 1, they turn into this yellow color. Now if I plug this into our UVs and reassign this material, we'll get the same result that we had before because this is our default texture coordinates and our default UV layout. But we can start to modify these texture coordinates and change how that mapping is done. So I'm going to separate the R and G channels, or the U and V channels of our UV map, by creating a component mask. And I'll have one that's just the R channel, and I'll have a second one that's just the green channel. And then we can recombine these through an append vector node. So now we have the same thing as before, but now let's start to apply some math nodes in between. So now I want to multiply our red channel. So I'm going to create a scalar parameter by holding down the S key and clicking, and we'll call this tiling X, just like our Megascans materials were doing earlier. So you can see now as I increase this slider, it's going to increase the amount of tiles in our scene. And if I decrease this, it'll do the opposite. And now we can do the same thing for our Y channel. So swap this out, add another multiply, and rename this to tiling Y. And let's plug in our texture sample again. Now we can increase the tiling in Y and the tiling in X. And if we set this to 2, we can see we have 2 perfect tiles on our cube here. And we can do any math operations to our texture coordinates in this way inside of Unreal. So if we create something like a panner node, I'll plug this into our coordinates, and then we need a speed input that is a 2 vector. So we'll need to combine 2 floats into a vector that has 2 pieces of data, X and Y. Now I'll make another scalar parameter by pressing down S and then clicking, and we'll type in speed X and set this to 1, and then I'll duplicate this and rename it to speed Y. Now I'll do the same thing as above and create an append vector. Now if it's not obvious from before, vectors don't have to be 3 numbers like an RGB vector. It's anything more than 1 or less than 4. And now you can see with this panner node, our textures are moving in X and Y at the same time. So if I change the Y speed to 0, these will just be moving on their X axis, and vice versa. If I take speed X to 0, it'll just be moving on its Y axis. So as you can see, UVs work a little bit differently. We're almost reverse engineering them before they're input into our textures when we're inside of Unreal. Whereas if you're used to Blender, or when you're creating your assets for the first time, we're simply taking the faces of our geometry and moving them around in the UV coordinate space. So now in modeling mode, I can create a cube and apply that same texture. And by using the UV editor here, we can edit our UVs in the same way we would in Blender or Maya. So here we can take different faces and we can move them around in UV space without affecting the rest of our object. Or we can auto UV and unwrap our entire object.
So one technique that's used all the time in environments for games that's not used as much in VFX workflows are trim sheets. So this is an example of a trim sheet and how it's used in games. So it's like a tileable texture, although it's really just repeating on the x-axis. In this way, we can combine many tileable textures into a single UV tile. And instead of explicitly texturing our object like you might do in Substance Painter or Mari, we'll move around the faces in our UV editor to correspond to the texture of our trim sheet. And using Unreal 5, we can take 3D displacement combined with these trim sheets to create high-resolution assets all inside of Unreal Engine. So we're going to create our own trim sheets and use them as 3D displacement and combine them with several different displacement texture maps to create this high-detailed cave wall. And we'll get some high-res displacements from the Substance 3D library and combine them together to create our own trim sheets and then use those as a displacement in Unreal. So let's get started.
So now we've learned a little bit about Sequencer and we've blocked out our scene. Now let's start creating some of the high quality geometry detail that we're seeing on the walls and the floor by using displacement textures. So I'm going to take a floor plane and just drag it off to the left here so I don't interfere with anything inside of our tunnel. But now we're going to use the modeling tools and Quixel to create some high resolution displacement geometry to create the rocky floors and detailed walls that we saw in our tunnel. So I'm going to go to our assets folder here and create a brand new folder called Cave Walls and Cave Ground. And let's start with our ground. So I'm going to create a new rectangle in our scene. This will be a little bit hard to see on top of our floor plane, but let's click anywhere here. So most Quixel textures are scanned at a 2 meter by 2 meter resolution. So let's change our width and depth to 200 and 200 and press accept. Now let's drag this up above our floor plane and let's find a Quixel texture that we can use for our ground. I'm going to right click here and hit add Quixel content and let's type in brick and go to surfaces. And I'm going to choose historical. So it's always nice to try a couple out. So I'm going to download the Roman stone wall, the Fort stone wall, and I'm going to download the Roman brick floor. And I'm going to use this Roman brick floor for our first test here. So I'm just going to click and drag this material and apply it to our floor plane. So with an object like this, we can go inside here and we could crank our normal strength to something really, really high. So let's set it to 5. And we can see we get a lot of contrast out of our ground. But the closer we get to it, we can quickly see that it really is just a flat plane with a texture on top of it. But we can turn this plane into high resolution geometry pretty quickly using the modeling tools. So we have our base color, our normal map, and we have this ORD map. So this stands for occlusion, roughness, and displacement. So these are packed into the R, G, and B channels. So if I uncheck G and B, we'll be seeing our red channel, which is our occlusion of the ORD map. So this is ambient occlusion. The green channel is our roughness map. So this is plugged into the roughness channel of the material. And the blue channel is the displacement. And this is a data map which we can use to deform our geometry. And any value that's above 0.5 will push up above our plane, and anything below 0.5 will push down. And if we're going to displace our geometry, we want to use the highest quality possible. So in this case, I'm going to download the high quality 4K version of this texture. So right now, if I go to wireframe mode, we'll see all of the polygons in our plane. And because this is a primitive, it only starts with 2 polygons. So we don't have nearly enough resolution to displace up or down. So let's scroll down here and select remesh. And this way we can give it a target triangle count to tell it exactly what resolution we want. Now we're going to go extremely high resolution to get an initial displacement, and then we'll simplify the mesh down once we're happy with it. So instead of 5,000 triangles, we're going to set this to something very high, like 1 million. Now this will take some time to calculate, but now let's press accept. Awesome. Now when we go back to lit view, it's not going to look any different, but now it's prepped so that we can add our displacement. So now let's go to the Deform tab and select Displace. Now by default, it's giving us a Perlin noise displacement, which we can see in 3D here. But we want to give it an image texture, so let's select Texture 2D Map. Now let's drag our ORD map into the displacement map slot. And let's select the blue channel, which is our displacement channel. And now you can see, if we look up close, we have some really nice displacement of our geometry here. Now, depending on the mesh, you might want to increase this displacement intensity. So for now, I'm going to set it to something pretty high because we can always scale this mesh down in Z later on. So now we can see the wireframe mode, and now we don't even see a wireframe because there's so much geometry in our scene. Now, hypothetically, we could keep this as is by just converting this to nanite. So the way you do that is either by opening the static mesh editor and enabling nanite support, or under any static mesh, you can right click it and enable nanite on this mesh. But even so, this is extremely high resolution and beyond anything that we'd ever need. So let's go over to our mesh ops and press simplify. And now because we have such a huge amount of polygons on this plane, we can change our target percentage to something fairly low, like 20. So now that that's done calculating, we can look up close what the resolution of our simplified mesh is. And I would say for what this is still fairly high, even for Nanite. So I'm going to drop this down to 15%. Cool. And we have a couple different simplifier types that we can select from here. And we can see that QEM mode is their fastest, but we want to switch over to UE standard, which is the highest quality reduction method that they have. And now we'll accept that. Awesome. And now we have our high quality displaced mesh that we can put into our scene. So let's just make sure to save that. And let's rename it to SM_Roman brick floor 01. And why I like to increase the amount of displacement a bit beyond what looks correct is so you could take a mesh like this and intersect it with other surfaces like other ground planes or water materials, and you'll get this nice natural intersection between the two surfaces. Otherwise, we can just scale it down by Z and just decrease the amount of displacement. And now when you compare the two, look at how dramatic the difference is between our 3D displacement version and the original 2D texture. So before we start adding geometry into our scene, I think it's really important to make progress renders as you're creating your scene. This will make sure you're on the right track. You'd be surprised how many times you can take a step backwards as you're finishing your environment. So this will keep a steady flow of progress and you'll be able to see your scene transform in a couple renders. And I want you to get used to using Movie Render Queue and rendering out of here, even if it's just for still frames. So if you click on this clapper board on the bottom left, this will open up Movie Render Queue. Now, just in case, if you click these three dots, there is a legacy movie scene capture system, but this was used in Unreal 4 and has a lot less features, so you definitely want to be using Movie Render Queue. So when you click this, it'll create a new render job with the name of your sequence. It'll automatically select the sequence that this was created from, and it'll grab our master level map. And just click Unsaved Config to look at all of our render settings. Now this Add Settings button on the top left is where we'll have all of our different options. We'll go in detail on each of these when we go into our final render for this environment, but for now we'll just use the defaults. Now if we want to render what we're seeing in our viewport, that's what's known as a deferred render, which is automatically added to your scene. We can add path traced renders. We'll get into path tracing renders later, but these deferred render tabs are different AOVs generated by the game engine renderer. So we don't need AOVs for now. We have render main pass as checked, and that's all we'll need. If you're curious, these post-process materials are where we can add different data AOVs, and by default we have world depth and we have motion vectors, but you have to render out an EXR image to get these, so you could use those in a compositing software like Nuke. So just to get up and running, we can keep everything in our output directory the same. If I hit these three dots here, we'll navigate to where this is inside of our project, and it'll default to our project folder underneath saved, and it'll create a new folder called Movie Renders. And I'll just add another Raya01 folder there. So if you see here, there's a couple terms we can put in between brackets to auto-name our renders. This list on the bottom here, like sequence name, job name, frame rate, as well as version, frame number, all of these different options are all things we could put in between here. So if I wanted my camera name, I would just right click this, copy it, and paste it here. You also have this drop down if you type in two brackets, but we'll go back to the default of sequence name. And instead of dot frame number, we'll go underscore bracket and we'll change it to version. Then let's just uncheck override existing output. Unreal should be smart enough to know what version we're on each time, but just to safeguard ourselves, I'm going to uncheck that. And for the playback range, by default, it'll render whatever's between our green and red in and out points within Sequencer. And you can change these with the left and right bracket as a hotkey. But for now, I'll undo that, and we just need to render our first frame. So let's go back to Movie Render Queue. We'll set a custom playback range. So I have my custom start frame at 0, and I'll set my custom end frame to 1. One last thing we'll want to do, sometimes Unreal needs to warm up its render. Things like Lumen or Temporal Super Resolution, which is Unreal 5's anti-aliasing method, take some time to warm up. So we'll need to add some engine warm-up frames. So we have render warm-up count and engine warm-up count. The render warm-up count will actually render out the frames beforehand, but it won't save any of them. Whereas the engine warm-up count will just run the game clock for however many frames you put here. So things like Niagara particle effects will run, but we don't necessarily need to render those. We just need them to cache in our scene. So I'll just change the render warm-up count to 64 just to be safe, and we'll keep everything else the same. Now we want to save this preset so we can keep going back to it. So let's save it here and go to UEVFX, Sequences, and let's create a new folder called Configs, and we'll call this MRQ Blackout Render, and press Accept. And now when we're in Movie Render Queue, we have this drop down and we'll have all of our presets right here. So now that we have our first preset, let's hit Render. And the first time you use Movie Render Queue, it'll usually have you compile shaders. So that's just part of the process, but after you do it for the first time, it shouldn't happen again. And now the first time I rendered out this blueprint, Echo bounced around the scene. And this is because this asset was created as a game controller. So I just scrolled down to the bottom here, and under activation, I deactivated character movement. If we want to open up any blueprint from the editor, we have two quick ways to do that. You can right click on this graph icon and open the blueprint editor, or you can hit Control E. And we can see at the very beginning, this event begin play executes, and we have two different scripts going on. The first one is that Echo is moved to the floor, and if I double click this, I can see exactly what's going on here. But nothing from this setup would tell me that she would bounce around. But if you see this set movement mode and this character movement reference, this is in reference to this character movement component, which is some C++ code that's used to control characters and things like walking speed with some set parameters. So by disabling this entirely, we're not using her as a game controller input in this case. So this should fix our renders. Another thing we can do for now, at the top here in animation mode, by default it's set to use animation blueprint, and animation blueprints are used to drive animations within gameplay. So you can create new node graphs that tell this character blueprint what animations to play based on the state of that character, whether they're running or walking or jumping. You do not use this for VFX or rendering, only for gameplay. These are simple logic trees and state machines that will adjust how the characters are animated during gameplay. They'll use animation assets and decide which animation is the right one to use. So don't even worry about learning this whatsoever when you're first getting started. So I've gone ahead and I've made a couple extra displacement meshes for different rocky ground textures that I found within Quixel. So we have a couple options that we can bring into our scene. Now, one thing to note here, because we made these 2 meters by 2 meters long, if I set my snapping to 50 units here, and I alt and drag these assets across, all of these textures are tiling, and because I'm moving them an exact number of pixels away, we should have a perfect intersection between our two assets. And this will help us tile our geometry when we move it into our cave. So I'm not concerned with matching this floor perfectly one-to-one. I just want to see whatever looks best and believable when compared to our character here. So let's look at these different floor planes in action. So we can see this one is a bit big, but it might have the shape language that we want. So if I scale this down to 1, let's see how this looks tiled in our scene. Awesome. So we'll go with this one for now, which is the MI Roman Stone Wall 4K. And let's just continue to instance this perfectly across our floor. All right, and now we have a pretty nice ground plane working here. So the next step is to create some high quality 3D displacement on our walls. But we can see in the reference image here that we have a lot more detail in different design elements, while also having this square brick displacement running through it. And we have a hallway on the right side here. We'll also have to create some trim pieces for the opening of that hallway there, and around each segment of our tunnel. So let's start with the hardest thing first, which is going to be these walls, and finding interesting and easy ways to create these design elements, which won't exist in the Quixel assets. Alright, so I want to go over how to take displacements from Substance Designer or Substance Painter and turn those into images that we can use inside of Unreal. So you could create this from scratch, or you can download anything off of the Adobe Substance 3D Assets homepage. Just know that you don't have to exclusively stick to Quixel textures In fact, if you do, your work will start to end up looking like everyone else's, so it's great to either create your own materials or find them from somewhere else. But I'm going to start off with this Labyrinth Ancient Brushed Desert Stone material, so we can get some of these three-dimensional shapes that we'll see at the bottom of our cave wall here. So I'm going to download this SBSAR file, and now I'm going to bring this into Substance 3D Painter. So in Substance Painter, we'll create a new project. You can pick the Unreal Engine 4 template, and I've prepared a simple plane material where the single face takes up the entire UV tile, which I'll also include as a download down below in case you need it. We'll change our document resolution to 4K because we want our displacements to be done in as high of a resolution as possible, and we'll click OK. So now we have our simple plane. Now let's import our texture. So I'll click this plus icon on the bottom here, and then click Add Resources. And then let's navigate to our .sbsar file. And then we'll import this into our current session. Now we can just click and drag this onto our plane. And then we'll just want to verify that we have a height channel, which is what will be exported as our displacement. Now from here, we can go right to Export Textures. It's automatically chosen our Unreal 4 output template. And let's export this as a 16-bit PNG. But one thing we'll want to do is we'll want to go over to Output Templates and find our Unreal Engine 4 Packed preset. And if you look here, we haven't included our height as a displacement map. So in this case, we don't need our emissive map, so we can just rename this to displacement. And then we'll click and drag height over this RGB box and choose gray channel. And now we'll export our displacement properly. Now we can go back to our settings tab and just press export. And now if you click open output directory, we can verify that we have our displacement material here. I'm also going to go ahead and do the same thing for our terracotta tiles material. All right, now that we've exported some displacement maps out of Substance, I'm going to bring them into Photoshop and combine them together so we can create our own custom trim sheets based on these pre-existing displacement maps. So if you click and drag any of these displacement maps directly into Photoshop, it should create a new composition, and we want to make sure it's set to 16-bit. And I can verify this because it says RGB/16 at the top of the document. Otherwise, just hit the image dropdown and go down to 16-bit. And let's add the rest of our displacement images into our document. Now, working with displacements in Photoshop, it's good to know that 0.5 is our middle gray. When a pixel is at 50% brightness, it won't move up or down, but the more white or dark we make a pixel, the more it'll push our geometry up or down. And if you ever want to reduce the amount of displacement that we get from any layer, we can just reduce the opacity so that it starts blending into our middle gray layer underneath. So now what we want to do is start to mimic some of the design choices that we're seeing on the wall here. So we can have the bricks towards the bottom, then we have another row of these glyphs that are coming across. Then we have more of a rigid stone texture, then another wavy glyphs pass, and then the rest are filled with this rock texture. So the way that we're going to do this is we're going to displace this geometry 2 times. So I want to make a clean version which has some of the glyph details, and then we'll do another displacement layer with a rock texture on top of it that we use to distort the entire mesh after we've applied the glyphs to them. So we can see that most of these stop about halfway up the wall, so we'll try to recreate that in our texture here. So right now I'm going to isolate the middle portion of our texture by pressing the mask button on the bottom right hand side. And now to reduce the size of this terracotta displacement, the wavy displacement in the middle, I'm going to go to the top and scale it to exactly 50% of the size. And we want to keep this exact so that way our entire displacement mesh will tile perfectly. Now I'm also going to duplicate this terracotta displacement and just mask around these trim pieces on the top and bottom because we can duplicate these, rotate them around and flip them and reuse them in a couple different ways. And that way we can create these different sections of the displacement. And if you ignore the brick texture here, you'll see that most of our displacement is going to be on the bottom section of our wall. And it seems to fade off towards the top. So let's recreate that. I'm going to take our middle gray color here and create a simple linear gradient that fades off in opacity. Once I drag this out, now we can take this layer and stretch it and transform it around and even fade it slightly so we get a little bit of detail back in our displacement, but we still have that gradient going into middle gray.
Now, if I look at this middle section, I can see it has a lot more contrast than this bottom section. Our darks are darker and our brights are whiter. But if we look at our reference, it looks like this bottom section should be popping out more and have more contrast inside of our displacement. So to adjust the contrast, I'll just make another levels by pressing Ctrl L. And now we can bring up our black levels to create darker darks and bring down our white point to create brighter whites. And as a bonus, if you gamma down, this will create more contrast overall, and now these should pop a lot more. Now we need to create this gap in between our wavy lines and our glyphs at the bottom, so I'm going to use this little section from the top to break up the area in between them. And as you're combining your different displacements together, you should definitely know about the overlay blending mode. And this is useful because it'll keep the middle gray values the same, but it'll make anything below middle gray darker and anything above middle gray brighter, just like displacement. This is really similar to the multiply blending mode, but multiply is going to be a little bit different because if you multiply two displacements together with a 0.5 middle gray, 0.5 times 0.5 is 0.25, and then you'll make your entire displacement darker and react differently if you just multiply displacements together. You can also use the lighter color blending mode, and this will only blend pixels that are brighter than the pixel underneath it, so that we're only adding on top of displacement and pushing pixels out. And by combining different pieces of our substance displacement maps, this is where I ended up. All right, and once you're happy with the displacement, we'll go to File, Export As, and I'll make sure to set our format to PNG, and then we can uncheck transparency because we don't have any transparency or alpha channel in this image, and then press Export. All right, now that we're back in Unreal, let's do the same process as before, and we'll create a new rectangle. We'll make sure that it's set to 200 by 200 centimeters. We'll scroll down to Mesh Ops and click Remesh and set it to 1 million triangles. And now let's import our displacement. Then we'll go to Deform, Displace, change it to Texture 2D Map, and import our image. And now we have our nice three-dimensional displacement. So if we look at the result, we can see we have a lot of the same telltale signs as our reference. Again, we're just trying to match the spirit of it, not get a one-to-one recreation. But the one thing that is missing are these little stone bricks underneath everything. So let's do another displacement on our surface to get more detail out of our walls. So let's take the displacement from our fort stone wall and also apply this to our plane. So go back to Displace. Now I'm going to click on our fort stone wall material and browse to our folder where we can find our displacement. And now instead of Perlin Noise, let's go back to Texture 2D Map, bring in this texture map, and select the blue channel. And now you can see we get some nice breakup on the top of our mesh. For this, let's increase the UV scale. So I'll just double this so that our displacement has twice the tiling. And then we can decrease our displacement intensity down to 7.5. And let's press accept. Now let's duplicate that fort stone wall and apply it to our material, but we'll need to double the tiling so that everything lines up correctly. So at the top, we'll change our tiling in X and Y to 2. Now that we're happy with this, we can simplify our mesh and we'll change our target percentage down to 18. And now we have our wall asset. Let's bring this into our tunnel and see what it looks like in context. Also make sure to save this asset and let's enable nanite support so it runs a little bit smoother inside of our scene. So this is cool to see in context, but we have an obvious problem where we need these to curve like the tunnel in our reference. So this is really simple to do. Let's just pop back into modeling mode. Let's browse to our static mesh and make sure we have a duplicate as a backup because whatever change we make to this will happen to the static mesh file and we might not be able to recover it. But now if we go to the deform options and click warp, we have a couple different ways that we can bend our asset. So the default operation is bend, and we can see that the arc that this is going on. So if we just rotate this in Y by 90 degrees, and I can do that by having our snapping set to 90 degrees here, now our asset is bending just like our walls. And I'm going to reduce this just a bit from 90 degrees to 75. Awesome. And now our walls bend roughly to the same shape as our block out. I think we could scale this up just a little bit. So increase this to about 1.2. And let's duplicate this and flip it around for the opposite side. And now let's add a couple more instances down the length of our tunnel. And by the way, we'll have to re-enable nanite support every time we update this mesh using the modeling tools. And now our cave is really starting to come together. The one thing that I'm noticing is our textures on the walls are getting really contrasty though. I'm going to go over to the albedo controls
and reduce the contrast down to 0.6, and then we'll reduce the brightness down to about 0.4, 0.3, something like that. This is looking great. So let's just make a new displacement so we have something symmetrical to lay across our ceiling. So I'm going to fast forward through making the ceiling displacement here, but the big idea is we just want something that we can duplicate down the center of our ceiling. And to do this, we'll need to be able to tile this in both directions. So we'll need to tile it down the length of the tunnel and also have it so it'll intersect with our cave wall pieces. In this way, all of our geometry will line up if we apply that same 75-degree bend angle to each one of our modular pieces. So once you're finished populating this throughout the scene, make sure to kick off another progress render. Use that blockout movie render queue config so that we can save our progress and look back at it at the end. So one thing we're going to have to build are these trim pieces that go along the different segments of our tunnel. So let's take a look at how we can build these using Quixel assets. And the easiest way is going to be by downloading these street curbs. So there's lots to pick from here and they all work for what we're doing. But if you want to get the exact one I used, you can type in code SEPXW. And when you do that, we'll have our one asset pop in here. And this will have a modular kit where we'll get these two different pieces. So in order for our entire scene to line up and tile correctly, we're going to want to take one of our 2x2 meter planes here, and let's just make a copy and drag it off to the side. And then let's drag and drop our street curbs into the scene. So from here, I'm going to disable snapping. So the big idea here is that in order to make trims that tile in the same way that our tunnel will, is we have to make sure that these will fit inside of this 2x2 meter square. And as long as we do that and we keep them within the bounds, they should be able to tile efficiently. Now, if we just did this, it would be pretty boring. And if we look back at our reference, you can see that there's about 4 or 5 pieces here. So let's just build out 4 that tile together, reduce the size of these down to 0.5 each, and then we'll select both of these and make another duplicate. And now that we have these within our 2x2 meter square, now we can move these around and adjust them individually to give them a little bit more randomness and rotation, just little nudges in different directions. Now I'm just going to select all 4 of these and Alt click and drag to duplicate them. So we'll have 2 here. And then I just want to make another pair that has a different sort of tiling. So let's turn our angle snapping back on, rotate this and move this into place. And that'll already give us a very different result just by rotating it. But then let's disable our snapping there and just give it a little bit more variation between all of our different objects. And now we want to combine these into a single mesh. So to do this, we're going to select all 4 of these, and then we'll go into our modeling tools. And then under create, we'll press merge. And this will create a new object. And from here, we'll call this static mesh underscore cave walls trim 01. And I'm just going to press Control A to copy that. Now let's press accept. And then we'll do the same thing on our other piece here. Go to merge, and then I'll paste in that name, but instead change the label to 02. The other way to do this is to select all 3 here, go to actor, merge actors, press the merge key, go to cave walls, and then save them in the asset folder. And now this way we have 2 pieces where our pivot points are correct. They're in the middle of each of these trim pieces. And now we can do the same thing in our tunnel by bending them using the same 75-degree angle to line them up inside of the tunnel. So let's go do that. So I'll drag this asset in from the content browser. And one thing that I experienced is that after merging these together, that the LODs were a little bit broken. So it would pop in between bent and the original straight look. And this is because the LODs didn't regenerate when the modeling tools changed the geometry. So by changing this to a nanite mesh, this will remove our LODs and fix our problem here. So now we have our bent asset here. One thing that we can do with any object is if you hit the Alt key and then the middle mouse button, I'm going to click on the middle mouse button, not scroll it. This will allow us to offset our pivot. And then you just have to right click on your asset and go to pivot and then set as pivot offset. At least this will give us a slightly more accurate position. And now when we select our cave wall, I'm going to copy that location. I'm going to paste it here. So this will make it easier for us to line this up with the center of our wall. So let's go back to our sequencer so we can check this through the lens of our camera. And we have this wall piece right next to Echo here. Let's go to the rendering tab and change our visibility to off. So we'll have to add another piece of cave back here. But at least as a start, we can move this onto the edges of our cave wall. And let's just line this up perfectly. And feel free to scale this up and just fine tune this as we get it into place. Especially in dark environments, you could add another light. Otherwise, you can just go to unlit mode, and that'll make it a bit more obvious when things are intersecting or not. Cool. Now at least we've got these blocked into place. Now let's just change the texture here. So let's tint it so it's a bit closer to the same color as our stone. So I'll go back to unlit mode. We'll go to the albedo tint, and we can tell this cement color is a bit too bright. So let's bring down our value. And now the rock is a bit more red, so I'll tint it that way. And when you add a color, like I'm adding red, it will get brighter. So sometimes you have to just bring that down to compensate. And we'll just nudge it a little bit more yellow. Now those match. We can go back to lit mode. And now they're a little bit brighter just because of the nature of our light, which will also change around the lights in just a little bit. But I'll cheat this just a little bit darker so it draws a little bit less attention to itself. Cool. And now we have a trim piece in between each one of our tunnel modules. So now I'm just going to go ahead and add these pieces between each piece of geometry. Before I do that, just make sure to bring in our other variation of our trim piece so that we can alternate these throughout our tunnel and add some variation. And we'll apply our bend modifier in modeling mode. Now the last step is to add in this hallway that we're seeing in the reference. So we can do this by doing the same thing we did at the beginning and adding a Boolean operation to our gray blockout mesh here. So I'm going to navigate to where this mesh lives. I'm going to duplicate this and call it Boolean 02, and I want to make sure to assign that new static mesh to this one, and I'm going to assign that Boolean to this blockout geo right here. And we're going to create another Boolean. So I'm going to create a cube, and we'll just fill out this shape. So there we go. That's all we need. And now let's go back to our modeling tools, and we'll select our Boolean 02, and then we'll select the cube that we're going to use as our Boolean in this case, and we'll select Mesh Bool. And now we can see we've created a hole in our geometry. And we could adjust this if we had to here. So I'm going to close this so we don't have any of this half transparent lighting here, but also when we disable our sunlight, a lot of the lighting issues we're seeing will go away. And we'll press accept. Awesome. And now we could just duplicate our floor here, and we could use this for our wall, and we'll just move that into place. And then we'll use our grid snapping so we can keep our tileable material and texture all working in the same way. Now uncheck snapping, and we'll move this into a position that looks a little bit nicer. And I'll just scale this down so it doesn't look exactly like our floor and looks a little bit closer to the walls that we have inside of our cave. Okay, awesome. And then we'll just have to do one last Boolean operation to get rid of the little bit of spillover we have here. So I'm just going to grab these two actors on screen left here, and we'll combine these into their own actor, and we'll call this SM Cave Wall Interior 01. Now we can turn their visibility off, and we'll bring our new object into the scene. We'll just line that up by height. Okay, great. And then I have our original Boolean meshes, which I've hid, but we'll turn their visibility back on just to make sure we know how big they were. And let's do the same thing that we started with, and we'll go back to our modeling tools. We'll create a new cylinder on the floor, change the radius to 200. We can keep the height at 200 as well, and then we will rotate this into place. And I'm just going to make sure this piece of wall is behind our trim here, so I can see exactly where we need to cut that off. And now this will make it a little bit easier to dial in the exact position of this cylinder. Cool, something like that. And we'll just make sure that intersects. So now we have our cylinder Boolean. And now I can type in bool. Something in the search bar here, I'll type in bool, so the cylinder underscore bool shows up. And if I hit shift and backslash, this will create that vertical key that looks like an L. And then if we enter in something else after this, we can search for two different things at once. So I know this piece is our cave wall interior. So we're searching for Boolean and the cave walls. So now I can select this together. So select the cave wall first and then the Boolean. And then I'll go to mesh bool. and we can see exactly where that cut is taking place, and it looks good to me. So let's press accept. And now we have our trimmed wall piece. We'll just line up these now that we've pushed it back slightly and make sure those intersect. Now let's go back to our sequencer and double check that we've got everything good to go. And let's check our reference. And I think we're in a pretty good spot where our blockout is looking correct. The last thing we have to do here is add in these torches. So let's do that. And then we'll move on to my favorite part, which is creating the lighting and atmosphere inside of the scene. So we'll snap out here and we'll just grab one more Quixel asset to round this out. So I'll right click in the content browser, go to add Quixel content, and I searched around and found this tree debris asset, which is just a simple log, which I think will do the trick for what we need. So we'll download this and add it into our scene. Then we'll go to Megascans, 3D assets, tree debris, and we'll drag this in and rotate it around. Now let's check through our viewport camera to see where we should place it to match our reference. Cool. But for now, we'll just try to match the angle and position roughly. So we'll have one there. I think it's probably better to have the thicker part coming out at the end and it getting thinner as it gets towards the wall. So we'll start there and then we'll duplicate this and move this other one towards the back of the cave. Awesome. Well, that should do it for the geometry portion of our scene. And hopefully you have a really clear understanding of how you can take both Quixel assets and textures from other softwares and turn them into 3D assets inside of your scene, and use the modeling tool set inside of Unreal to help you block out your scenes in a really fast way. Now let's move on to the lighting. So now that you have a bit of a primer on how lights work and the general theory of how we should be thinking about lights creatively, let's use that to approach the lighting inside our scene. So when comparing our reference, the most obvious difference is the color of the lights, and it's also that sunlight that's pouring in from screen right. So let's tackle those things first. So for now, I'm going to switch from my master level over to the Raya 01 lighting level. And one thing that you can do, if you press this gear icon on the top right, you can select only in current level, and this will only show you the actors that are in that level, which is one of my favorite reasons to use levels in this way. So we had these lights outside so we could preview things in our asset zoo over there, but we really don't have a need for it anymore. So let's hide a couple different things. We can turn off our sunlight completely. We can just delete the volumetric clouds out of our scene because we're not going to see those anymore. And if we don't have a sunlight, there's nothing to illuminate our sky atmosphere. So I'm going to go to the rendering tab here and uncheck visible as well. And if we ever want to go back to our assets, we can always turn those back on and keep those live in the scene. So all that leaves for now are our 3 point lights and the light coming from our skylight outside. So I'll turn off the skylight as well, since we won't need that. And let's turn on our point lights. So first things first, let's take our point lights and let's turn those to a nice orange color. Whenever I'm using orange lights, I would recommend using this use temperature button. This allows us to change our color temperature in Kelvin, and sometimes by limiting the amount of colors we can use to the ones that exist in real light sources can help quite a bit. So 2500 is the magic number for anything that's fire. You could also set this lower and it'll start to turn red, but I like to keep it somewhere between 2000 and 2500. Now this can be really strong, so if I change that in our foreground, it's really going to change the color of our skin tones, which is another thing that we'll want to keep in mind. We don't want to go too crazy on the skin tones of our actress. And if we compare the two now, it's looking quite red. So I'll cheat this to about 3200 in our foreground. Now, one thing that we'll want to check for on our background light is our attenuation radius. This attenuation radius is set up so that we limit this light so it only appears inside of this bounding box, in this case, a bounding radius around this light. But it's important to know that if this is set too low, no amount of light will escape from it. And that also means that no amount of reflections will appear outside of that radius. So this is helpful if you have a ton of different lights in your scene, but because we're not going to go overboard with the number of lights, we're just going to have a few well-placed lights in our scene. We can set this to something like 3500, and you can see now we get a nice specular hit going all the way into our foreground. All right, now let's create some new lights for our scene. We can add a spotlight and bring it over onto the screen right side, and we'll change this to something really blue. Typically, you would use color temperature. On the left is orange. The lower it is and the brighter it is, the bluer it will get. But I find that you can really crank this in blue, and anything above 7500 doesn't really change the color all that much. So I really just use this for warm lights. I find you can get a lot more control by going into extreme values this way. And you can see this is a fairly saturated blue-green over here. So I'll start on the left side here. Typically, you don't want to set your saturation to 1 because you're probably producing a color that's fairly unrealistic. Like the moonlight would never ever produce that color, so it'll feel a little bit more artificial. But we can start to just fish around here and find something that still is creatively interesting, but also matches our reference. And it's really helpful here. You can really separate the saturation from the hue. So if you know that this blue-green is the one that you want, you can keep that and just crank the saturation. Or if you know the color is slightly off, but you think the saturation is in a good spot, you can just change this hue slider here. So I think that gets us a pretty close match to what we're seeing. But now if you look at the angle of this light, we can tell by the shadows that there's a light down at the bottom of the screen going up and to the left. Personally, I think we get a little bit more shape by having it coming from above in this case. But if we wanted to match it to the reference 1:1, we could duplicate and we'll move it down into the bottom here. And let's rotate it towards our scene. And we can see here, if we move it on the Z axis here, this will get us closer or further away from the wall. So it's nice to get some sense of light direction here. We have all this high-res geometry, and we want to make sure that we're seeing the shadows coming off of that. But if we get too crunched and too close, we'll get these really sharp edges, and it's not so pleasing to the eye. But because we're in a real-time engine, we can try out a couple different things here. Especially when I'm blocking out lights, I will sometimes change this outer cone angle to 90 degrees. And this way our spotlight doesn't really have a direct cone angle to make sure that the shadows are generally what we want. And then we can always reduce that cone angle and focus our light a bit more. But if we go here, we can start to fish around and see what it looks like. You can even rotate the light up or down. And in this case, you can see rotation doesn't make nearly as much of a difference as changing the location of our light. So it's really good to start with the location first and then focus in the light from there. So if we want to keep it really low, we could keep it around there. And when changing the intensity of a light, I like to go in doubles or halves because this is changing the amount of exposure of the light by a single stop. So if I double this to 32, it's gone up another stop. If I double it to 64, that's another stop. And I do want to see what it takes to get this light to spill in and hit the left side of our wall, because it could be kind of interesting to have a nice cast shadow visible on the wall. But it does seem like we'll have to push that light to a really extreme brightness, and it kind of takes away from our character here. It makes you just focus on this really bright light in the scene. So I think we can go back to around 16, or at least we get a nice amount of intensity, but it's not drawing too much attention to itself. And right now I'm just fishing around to find some interesting shape on the wall. I think something like this is pretty interesting, where we get some cast light on the wall itself and the floor. So I'm pretty happy with that. I'll bring it away from the wall just a bit so we don't have quite as harsh of shadows. And I'll reduce this from 16 to around 10. And then let's reduce our cone angle to focus the light just a little bit. Cool, so we'll keep that there for now. All right, so one change that I want to keep is having our Echo character facing us, so we can have a little bit more practice lighting up a character. I think a lot of people end up focusing on the environment art side of Unreal, but in any movie, most of the shots are mediums and close-ups, something like this. So it's a really good practice to throw in one or two lights and see how we can light our characters in our scene. Now, even though we've changed the temperature here, we can also add some extra color by tinting the light color on top of the temperature. So I think I want to bring a little bit more red into this. And because this light is so close to our character, I think we can reduce that intensity from something 4 down to 2. A good general rule is you want the brightest thing in your scene to be the thing that you look at. So right now, the brightest thing in our scene isn't our character. It's actually this really bright light behind her. So I think we can reduce that light as well down to something like 2. But if we still want to get some light pouring back here, we can just duplicate that light and move it a little bit further back. And we can also place a couple secondary lights and just really reduce their intensity down to something very low, like 1 or even lower than that, just to fill in our shadows. We don't want it going too dark, and we want to always stay true to life, but we also want to be creative. So don't be afraid to cheat your light positions if it's going to make your image a bit cleaner. Now it could be cool to have a light back here. Again, this isn't matching our reference one-to-one, but to show that there's something beyond what we see in the frame. I think that's a really good way to add depth, is imply that there's something beyond what we're actually able to see, like this area on screen right here, or adding some depth to our tunnel. And I'm not sure how this will look, but we could try to tint this blue just to add a bit more color contrast to this, because it doesn't have to be a torch light. Usually it's a good idea to take an existing color in your scene, so you don't have like 5 different lights with 5 slightly different colors. Especially if you have torches, it wouldn't really make sense for fire to be 5 different colors if it's the same light source, which is fire. So I'll just right click on our light color here, press copy, and I'll find our point light in the back here and press paste. And we'll also want to reset our use temperature settings. All right, that's cool. And now one thing that we can add is another torch light to our torch here, which again, even though fire in this case would probably blow out our entire frame and be a lot brighter than her, we want to try to focus our light as much as we can. So I'm going to bring this as close to the torch itself as I can. And let's steal the color from this torch here. And set the temperature to 2500 Kelvin. And actually for the lights behind her, I'm going to change these to go a little bit more saturated. So I'll try out 2100 Kelvin here. And now we can see that this is what our background lighting looks like. I think this is in a pretty good spot. I think in the end, we might end up tinting that blue light in the far background a bit more orange. But for this light that we've placed in the foreground, I think this really helps give some clarity to seeing our actress here. And you can imagine that on set, you might place a light behind this wall and cheat it in so that we get some really clear lighting on her and we can see her face as clear as possible. But it does start to light up some of these shadowy areas and just spill all over our entire scene, especially in this area on screen right. So there's a couple things we can do. The first one is something called lighting channels. So in the details panel of this point light, I'm going to type in channel. So every object in our scene has these lighting channels, both the lights and the geometry in our scene. And every actor has channel 0 checked to true by default. So any light that we add will show up on every actor. But if we uncheck channel 0 and check channel 1, this will make it so only actors that have channel 1 activated will have that light appear on them. So we could enable channel 1 on our character here. We'll also have to go in and check channel 1 on our groom to make sure that shows up correctly on her hair. And this really isn't a bad option. But the other way we could do this is by adding a spotlight into our scene and making sure that we focus that light directly on her. So now based on the rotation of this spotlight, we can start to accent some of the lights that will appear on the walls, the floor, and screen right here. So this is pretty nice, but it starts to spill on our ceiling as well. So we can just focus this on the ground. And actually, let's reduce our cone angle just a bit. So I'll set this from 44 down to 30. And I'm also going to increase our attenuation radius. You can see if I rotate this thin line that's appearing here tells us that it's just barely reaching past this trim piece here. So I'll just increase that from 1000 to 2000. And if you want to get hyper specific, we could also reduce this cone angle even more to something like 20. And just be conscious of getting too particular with our cone angles and cheating things a little bit too much. Oftentimes, the more specific and granular you get with lights, the less realistic it's going to feel. We'll bring this up to something like 16. Now we'll do some dialing there. And let's also add in a second spotlight for screen right. We can try to get this off of the floor as much as possible because there we'll have some really obvious shadows or bright spots, which really makes sense when you can tell where the light sources should be coming from inside of our scene. Now we get a bit of a double shadow here at the bottom, so I'll just tweak this slightly and try to move that out of the way until we don't see it. Cool. So this gives us a pretty close match. We have some nice punchy, contrasty lighting, which is what we'd expect in a dark tunnel like this. It's really important to think of what story are we trying to tell. And I think in this case, we're trying to sell the idea that this is a scary underground tunnel and the mysteries that lie beyond. So having the blue color kind of helps reinforce this otherworldly fantasy quality that we have in the scene. But everything feels pretty believable and lit by torch lights. And we also have some really crisp, clean lighting on our actress that feels believable and integrated in the scene. We don't have any crossing shadows or anything obviously broken. So let's make sure to save this. Now, one last thing that we can do that really starts to elevate your shots and make them feel a lot closer to Hollywood movies is by adding volumetric fog in your scenes. And this is because almost every single movie set is using fog to add more depth and atmosphere into their scenes. And you'd be surprised how even comedies or less dramatic TV shows oftentimes will use fog. I'll call it a cheap trick, but honestly, it does add a lot more depth into shallow scenes. And we can see here that we do get a bit smokier and some dense fog in the background here. So I think this shot could really benefit from it. So the way that we add that into our shots is through an exponential height fog actor. Now, we added this through our environment light mixer early on, but there's one checkbox that we need to tick inside of here, and that is the volumetric fog checkbox. So we could set our fog density to something really high, like 1, and this will just crank it, and honestly, that already gets us very, very close to what we're seeing in our scene. But this is kind of hitting it with a hammer. But one thing to note is every single light in your scene casts volumetric fog, but if you type in volumetric into your scene, you'll get 2 options for every light, and that is volumetric scattering intensity and cast volumetric shadow. So certain lights in our scene, like our spotlights that we're cheating to get some additional light in the foreground, we're always going to be able to tell when we're cheating that volumetric light because we're just placing it in an impossible spot in the air. So on lights like this, I'll bring them all the way down to 0. We want to just make sure that any light that's casting volumetric fog feels justified within our scene, because this can get really dense really, really quickly. So you can see by just reducing those 2, and for that key light that we have on echo here, reducing that already clears out a lot of the dense fog that we have in our scene. Point light 5 is our blue light. We could crank this volumetric scattering intensity to something like 10 just to see what the effect is, and we get this really interesting otherworldly fog that kind of rolls in through the background, which I think looks cool. It does start to make this feel a lot less believable. So it's going to be a fine balance between what's realistic and what is just creatively interesting. And if you increase the intensity of your light, it will also increase how much contribution it has to the volumetric fog. So if I bring this up a stop to 16 and double it, this will start to increase our fog. But because our fog is still set fairly low to something like 3, it's not cheating it too much. So I think I'll keep this at about 1.5. And now because we have so much fog inside of our scene, that blue light is being played down quite a bit because we have so much density of fog in between our actress here and the fog in the background. So I'm just going to play around with the intensity. And I think it does start to break and become unbelievable pretty quick. So I think I'll leave this around 16. And I'll probably boost the saturation just a touch here. And now you can see if I enable and disable our exponential height fog, you can see this also helps silhouette our characters. We get a much cleaner read on the silhouette of her arm. And now her dark side, where the shadows are, has a much more graphic shape, which to me is just a bit more interesting. Whereas before, we have all these blacks going all the way into the background. So we don't read that strong heroic shape that we're getting once we have exponential height fog. Now, it's always good to do some housekeeping and just go through every single light and make sure it's doing exactly what you think it is, because there's a really fine balance between too little lighting and overlighting your scene. And I think in Unreal, it's more common to overlight your scene and just cram in a ton of lights. But we can see here we have less than 10 lights, which, again, if you try to think of if you were on a film set, what would happen, what would they do, what choices would they make given the physical location? And I think this is pretty reasonable considering 2 of our lights we know we're cheating to get this foreground light to match our reference. In terms of brightness, if you compare our shot to the one from Raya and the Last Dragon, it's actually interesting how they're using brightness to lead your eye. The storytelling of this shot is that we actually want to look at where Raya is looking down the cave, and that's right by this torch as the brightest thing in our scene. Whereas in our case, given that she's looking out and past camera, I think it makes a lot of sense in this case to make sure that she is the brightest thing. All right, well, I think for now, we've done a pretty good job matching the spirit of our reference and adding a little bit of creative flair given the changes that we're doing inside of our shot.
So now I'd like to move on. I'd like to add a little bit of movement. After all, we're trying to use Unreal for visual effects to make movies, and that means we have to make our images move, and a great way to do that is by adding effects elements like fire. So we're going to add some fire onto these torches and learn how to create looping elements specifically for Unreal and not just pull in any video clip that we have on our hard drive. We want to figure out how can we make elements that work best for the way that Unreal works as a game engine first. And then we'll add in some secondary particles, like some dust motes, some dust particles that are floating through the air, just to add another layer of movement. So stick around and we'll dive in to effects next. So when we're creating effects elements for Unreal, like this torch that we have here, we really need to rethink how we're going to approach elements entirely. Because we're trying to take something that we would do in comp and bring it into a real-time engine, and we want to create it in a way that works best for the real-time engine, not what works best for our previous workflows. So it's actually fairly straightforward, and what we're going to do is we're going to take a video clip like this torch element that we have here, and we're going to convert it into something that's called a sub-UV sprite sheet. This can take a video clip and turn it into a single texture that can be played back and looped infinitely inside of Unreal Engine. So instead of having a video clip and a video file, which doesn't feed into a game engine all that well, and we're going to convert it into a texture like this, where every single image here is a different frame that we're playing back. Now we can import this as a texture and just assign this material to a plane, and it will play back this torch animation. So there's two steps to this. The first is converting our video clip into a sprite sheet like this, and then we'll create our material shader inside of Unreal. So how do we create this torch element? Well, this original element could be stock footage, it could be a smoke plume, it could be anything. I'm just using a torch for this example. This is a simulation out of EmberGen. It was a little bit slow, so I'm just retiming it to be twice as fast so that when I play it back, it looks correct. But the tricky thing here is our final image is in an 8x8 grid, which means we have 64 frames to play with to create our looping animation. So if it's an 8x8 grid, we have 64 frames, which equals out 2.6 seconds of looping animation inside of Unreal. But we'd have to prepare this element so that it loops correctly. So if I just grab 64 frames, so if I start at frame 100 and have our end frame set to 163, which is 64 frames, we'll see at the end of this timeline, it does snap back to the beginning. And we need to do a little bit of prep work to fix this. Now I'm going to show you how to do this in Nuke, but the same exact method applies in After Effects. And if you have After Effects, I'll include a link for a script that you can run to create a contact sheet as well at the bottom of this video. So I've gone ahead and found a frame range that mostly works, even though it's not perfect. So I've set that to 134 to 199, which is 64 frames. Now how I'm fixing this looping problem is in these two nodes here. So all I'm doing is time offsetting our clip by 64 frames, and I'm fading in the ending here. So that's what is happening with this merge copy node. If you see this mix here, I'm just slowly mixing in the beginning of our frame range. And now by fading this in over the last 10 frames, you can see we now have a perfect loop where that seam isn't too obvious. Now this is a lot easier for things like fire, which are very organic and random, but this does require a lot more prep work depending on the type of element you're doing. But you could use the same methodology to make elements like campfires, magic effects, sparks, or even explosions. Now I've included a little bit of exponential glow as well to help us out. And it's also important, especially for fire, to not clip our texture. We want to make sure that the brightest value in our scene never goes above 1 because we don't want to clip any information. We can always gain this up inside of Unreal, but if we clip any of that information and lose it, there's nothing for us to recover inside of Unreal. And then most importantly, the last step here is to create a contact sheet node. So this is what will convert our frame range into this sub-UV flipbook. And it does this by inputting a frame range between 135 to 199. And importantly, you'll need to set the row order to top bottom and the column order to left right. And that way, at the end of each row, it'll start at the correct frame. Now I'm using Nuke Indie to prepare this contact sheet, which has a render restriction, which can prevent you from rendering a 4K square texture. It'll limit it by about 3,000 pixels in the height. But a quick way around this, whether you're in Nuke Indie or Nuke Non-Commercial,
is you can just crop this to 4096 by 2048 and reduce the crop size and split out these contact sheets into 2 or 4 slices and then reassemble the entire square texture inside of Photoshop. This is a little bit beyond the scope of this course, but you can also implement motion vectors. I'll include a link to this blog post by Clement Lazar. But by including a velocity pass along with our 8x8 sprite sheet, we can interpolate in between our frame numbers so we can create slow motion and reduce them down to an 8x8 grid of textures. So check that out if you want to go one step further. But now that I have our finished contact sheet, let's take a look at how to bring this into Unreal and set up our torch shader. We're back in our tunnel environment. Let's create our materials for our torches. So I'm going to create a new folder in our assets folder and call this torch. And let's create a new material called torch_subuv. And we'll open this up and I'll drag this texture into our project. And I'll include both the video and this contact sheet below, so you can download those by clicking the link below this video. So let me drag this into our material graph and let's do a couple things. So to set up our material the right way, I always like to set up these material settings first. So in this case, we do have a surface because we're going to apply this texture to a plane, but our blending mode we can set to additive because fire is additive and we're adding emissive light into our scene, and this will get rid of things that we don't need like the roughness or specular or metallic. And you can set the shading model to unlit mode so that we just get exactly what's in our texture and it's not affected by the lighting in the scene. So now let's plug this into our emissive color and let's start to preview this in the scene right away. So I'll drag this onto our torch, set a rotation to -90 degrees, and let's apply our material. And make sure to save this so our shader compiles. So now we can see our contact sheet. Let's rotate this 90 degrees so it's oriented. And now let's set up our animation. So if I right click in the material graph and type in sub-UV, we have a couple options. Just so you're aware, this particle sub-UV is for use with the Niagara systems. So we don't want anything under particles. So the two selections that we have are the texture sample parameter sub-UV and the sub-UV function. So let's select the sub-UV function. And this will give us a UV map that we can plug into our texture sample. Now it asks us for 4 inputs. For material functions, typically you'll need to add an input to each one of these or it will have an error in compilation. This isn't always the case, but you'll find this is often how the default material functions are set up. So when you see texture 2D, it's really asking for a texture object. So this can be a little bit confusing, the difference between a texture object and a texture sample. The only difference here is this texture object is only asking for a texture. So this is the simpler version of a texture sample, where texture samples will also ask for UVs. But it works the same way, so we'll browse to our torch texture, grab our texture object, and use our selected asset from the content browser. Now, if you ever get asked for a UV input, you'll want to type in texture coordinates. These are just our default UV coordinates, which you saw earlier when we talked about sprite sheets. And next we have sub images. So this is asking us what our grid size is for our texture object. So we'll want to create a 2 vector. You see it says V2, stands for 2 vector. So let's create 2 floats. So I'll press the S key and click down to create a scalar parameter, and we'll call this grid X. And then I'll duplicate this and call it grid Y. Now, if I make an append vector node, we'll be able to convert these 2 floats into a 2 vector, and we'll plug that in. And let's set both of these to 8. Now, the last input here is frame, and this is asking what frame are we on. So we have 2 options here. We can create a time node. So the time node is just like our tick in our blueprints, but we could also input a scalar parameter and give it a whole number for what frame we're on. But in this case, let's set it to time. And we could also do things to a time node, like we could multiply a time node by 2 and time will play back twice as fast, or you can multiply it by half and it'll go half speed. But we'll just keep it to 1 by default. Now in this case, because we've input our texture 2D and all of our other settings, we won't need this texture sample. But now we can see we get our fire playing back, but it's really slow. Let's set this to 24. And now we get our torch playing back correctly. in our viewport. So now we can make this smaller and we can line it up to the tip of our torch. But one thing that we can tell right away is that it's pretty dim. It has a sense of transparency and it's not very bright. So let's add in a multiply node. And I always like to add two different sets of color controls. One that's strictly brightness. So I'll make a scalar parameter and call it brightness. And I'll just go ahead and set this to 5 because I know we want this to be quite a bit brighter because it is fire after all. And we'll press save. And already that starts to feel a lot more natural. And then I like to also add in a vector parameter so we can always tint the color. So press down the V key and click. And we'll call this fire tint. And we'll set this to 1 by default so that it doesn't change the color unless we decide we need to change it later. So now we have our brightness parameter, our fire tint parameter, our grid parameters. Let's create a parameter for our time node. So we'll call this speed and set it to 24. And lastly, if we right click this texture object, we can convert this to a parameter. So we'll call this sub UV texture. And now if we had different fire materials, we could quickly swap this out in a material instance. Okay, great. So let's just clean up the size of our fire. We could cheat this to be a little bit thinner, and let's just get it a little bit closer to the tip of our fire, and we'll probably want it to be in front of our fire, so it obscures the tip there. And let's see what this looks like through the lens of our camera. And now we can hit Alt, click, and drag, and set this back on our other torch. Now, one thing when creating sub-UV flipbooks that's really important. So as you can see, this is a 4K texture. And because this is in a grid of 8, that means every single image is 512 pixels wide, which isn't that big. Obviously, our fire isn't taking up a lot of space in our scene. But one thing that happens with square textures in your scene, whether it's something I've applied to this plane or the tileable textures that we're applying to the other geometry in our scene, is they have something called mipmaps. So mipmaps are like LODs, but LODs are for meshes. And the idea is that the smaller a mesh is in screen space, the lower resolution LOD will be replaced inside the 3D scene. This helps so objects that are really far away, we're not loading in the full resolution mesh of something like a castle when it's really small on the screen and far away in the distance, so we just don't need all that detail. Obviously, we're not using LODs now that we're using Nanite in Unreal 5, but mipmaps are the LODs for textures. So depending on the screen space of a texture, it'll actually load in a smaller resolution. So what is a 4K texture here might be loaded in as a 2K texture or a 1K texture, and it ever becomes a 1K texture, which is 1024 pixels, and we divide that by 8, suddenly our squares are getting really, really small. So if you're ever loading in sub-UVs like this, one thing that you want to do is disable the mipmaps, and we can do that by changing our mipgen settings. So these are our mipmap settings, and if we set this to no mipmaps, it'll basically always load in our 4K texture. We want to force this because we only get so much resolution out of each one of our little squares, so it's definitely worth it when creating these sub-UV flipbooks. But now there's two things we can do to improve the look of our torches. The first one is that both of these torches are playing back at the same exact speed and size. So it's not the most obvious thing when we're looking back here because one is a lot smaller. But a simple thing we can do is create a material instance and rename this from mmTorch to mi and get rid of the underscore inst at the end. And let's apply this to our background torch. And a really simple way that we can change this is we can just change the speed ever so slightly so that they have a different clock, and very quickly they'll start to end up at different frames. Another thing we could do if we wanted to add in this control is with our time input, we could actually just add in an arbitrary number. So let's create a scalar parameter and call this time offset. And if we set this to something like 3.27, I'm just picking a random number, this will also give us a slight offset, and then in each one of our material instances, we can just slightly change that number, and very quickly we'll get a little bit of randomness between our textures. There's also nodes which communicate with the actors in our scene. So we can do a per instance random. So if you type in random, You can also create a per instance random, and this will generate a random number between 0 and 1. So we could just add this into our scene, and now any single instance of this material is going to have a random number assigned to it. So it's another easy way. We can also add an offset based on the world position. So we have our XYZ data here, which matches up to the XYZ of our world. So we can split this off. We can't break our pins like we can in blueprints, but we can make a component mask and isolate our channels this way. So RGB matches up to XYZ. And in this case, we'll just set it to our X value, and we can add this to our material. And now I can take this material instance, and if I move it in X, you can see as I move it, it changes its value. And that way we can get different randomization per material instance without having to make new material instances for every single flipbook. Now, why I'm creating this component mask here is because this time data, we can't see it here, but it's just another floating point number. So it's a single number, not a vector where we have combined data. But if we see XYZ, we know that it's 3 pieces of data combined into a single vector. So this is simplifying it. So I'm just adding a float to a float as opposed to adding a float to a vector. Typically when you do this, it would then convert our data into a vector, which could mess up some of our settings here because this is just expecting a scalar parameter in our sub-UV function. Cool. And then the last thing is if we had a torch in a underground temple like this, we would also expect the light to start to fluctuate because the fire is growing and getting brighter or darker. So one thing we can do is we can actually apply materials to our lights. So if I scroll down here all the way to the bottom of our lights, there's this section called light function material. And you can select any material here, but it's expecting a very specific type of input. So let's create a new material. We'll call it mm torch underscore light function. And let's apply that to our light. And a light function material, if I select our material node here, instead of a surface domain, we can select a light function domain. And now this just turns it into an emissive color. And now because there's no input, it's just changing our emissive color to black. So if I save this, our light would probably just turn off. So we don't want that. So if we wanted to just hard code in something so we don't lose our light for now, we can set a scalar parameter to 1. So now we're back to normal. But how do we add fluctuation to this light? Well, there are a couple nodes that are related to our time node. So we have time, but if we just plug that in, it'll just keep getting brighter and brighter with every frame. So we don't want that. But we can create a sine node. So sine nodes require a time input, but let's see what this does when we input this into our emissive color. So much like a sine function on a graph, it goes between 0 and 1 and just smoothly alternates between the two. So one thing we could do is we could add a clamp node, and then we could set our min and max values so it doesn't go to 0. So we could set this minimum value to 0.5 and hit save. And at least now we're not going to a black value. And like I was saying earlier with our time node, we could also multiply this and give ourselves a speed parameter. So I can type in speed, and let's type in something like 5 and make it go a lot faster. Cool, now this is obviously really fast and flickery, but this doesn't really have a sense of reality to it. It's good that we have some fluctuation here, but what can we do to make this a little bit smoother and believable? So if we want to add a lot of randomness, the easiest way to do that is to just plug a sine node into another sine node. So we have 2 back to back, and now if I hit save, we're going to lose our clamp here, but just to see the raw effect on the light. Cool. And now if I set our speed to 0.5, we get a lot more believable flickering, but in this case, it's black for most of the time. So one node we can use is called constant bias scale, which this is something we can't apply scalar parameters to, but we get a bias and scale option. But using this will help smooth out our curve. And now we get a pretty believable torchlight. So now let's just add our clamp back in at the end, and let's create a scalar parameter for our clamp, and then we can set that minimum value to something closer to 0.25, and we'll keep our max at 1. And now we have our speed that we can control later. We'll just bring in an add node, and do the same thing that we were talking about earlier, which is add a scalar parameter called offset. Awesome. Now we'll create a new material instance for our torch light function. And now let's go to our other torch back here, and let's apply our new material instance. And now we can add a slight offset and change the speed slightly. So we'll make this one a little bit slower, so it's a little bit less distracting if it's in the background. And now we have our two flickering torches with interactive light, and we've converted our movie file into an animated sub-UV flipbook.